Hello, Sridevi. Am I audible? Hello.
Yes, ma'am. Yes, ma'am.
Okay.
Hello? Hello?
Yes, ma'am. You are audible.
Ma'am. Okay, ma'am. Thank you.
Hello, ma'am. Am I audible?
Yes, miss.
Ma'am.
You are audible. Your voice is clear.
Okay.
Shani.
Sridevi, ma'am, you can mute.
Yeah.
all these layers which you mentioned, it is there for
പറഞ്ഞു.
Am I audible? Am I audible?
Yes, ma'am.
Yes, yes, ma'am.
Yes, ma'am.
Okay, okay.
Yes, ma'am.
So there is some internet disturbance at my home. I'm unable to see how many participants have joined. So we have any guests in our inaugural function joined? Principal sir, CTO sir, Meenakshi ma'am, Sri Priya ma'am. I'm unable to see the participants list from my desktop.
Ma'am, I'm Dr. Sipri. I have joined, ma'am.
Okay,
I'm Meenakshi. I have also joined.
okay, okay. If all the guests have joined, shall we start the program now? Hello.
Only 53 participants are available now.
It's
So,
okay, but no, they might be looking at the inaugural schedule that we're joining directly for the session. That might be the one of the reasons we have. If the dignitaries in the inaugural function, they have joined, let us start the program now.
Okay.
Ladies and gentlemen, respected principal, distinguished guest, invited resource people, participants, and all those gathered here. It is with immense pleasure and excitement that I extend a warm welcome to each and every one of you to the inauguration of the 6 days ATAL-sponsored online faculty development program on advancements in cloud and edge computing, research and industry perspectives, organized by the Department of Computer Science and Engineering at Adi Shagara Institute of Engineering and Technology. The event has been scheduled for 6 days from 5th January 2026 to 10th January 2026.
Let us begin our proceedings by seeking blessings from the Almighty for the success of our journey ahead. I would like to invite C.R. Krishna from S6 CSE, a student of our institute, to lead us in a moment of prayer.
सहनावतु सहनो भुनक्तु सह वीर्यं करवावहै दिव्यस्मिनावतीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः
Thank you, Krishna, for that prayerful beginning. A gracious welcome sets the tone for every successful gathering. To mark the formal commencement of this program, I now invite Dr. Deepa Devasi, Associate Professor, Department of Computer Science and Engineering, Adi Shankara Institute of Engineering and Technology, to deliver the welcome address.
Am I audible, ma'am?
Yes, ma'am.
Okay, thank you. Good evening to all. On behalf of Adi Shankara Institute of Engineering and Technology, I extend a very warm welcome to each one of you to our 6 days ASIT ATAL online faculty development program on advancements in cloud and edge computing, research and industry perspectives. This program is a significant initiative aimed at strengthening faculty competence, encouraging innovation, and fostering academic excellence. Today, we are honored to have with us Dr. Murali MS, Principal, Adi Shankara Institute of Engineering and Technology, who constantly inspire us with this vision and commitment. With great pleasure, we welcome you, sir, to this faculty development program. Dr. Meenakshi K, Director Academics, SIT, plays a crucial role in nurturing strong academics in our institution. With great honor, we welcome ma'am to this FTP. Next, I would like to welcome Dr. Sripriya S, Dean Research, SIT. Her guidance plays a vital role in strengthening research culture in our institution. Welcome, ma'am. I'm delighted to welcome Mr. P.B. Rajaraman, Chief Technology Officer, who adds great value to this program and helps to bridge the gap between academia and industry. Welcome, sir. We are honored to have with us Dr. Ramani V, Head of the Department of Computer Science and Engineering and Coordinator of ATAL FDP, whose dedicated efforts and leadership have been instrumental in planning and organizing this FDP. Welcome, ma'am.
Thank you.
Next, I welcome Dr. Sridevi R. Krishnan, Co-Coordinator of ATAL FDP. Her contribution and support in organizing this event is amazing. Welcome, ma'am. Next, I welcome all the heads of the departments of various programs, faculty and staff members of SIT for your presence. I extend a warm welcome to all the resource persons and participants who have joined us today for this FDP. I'm confident that this ATAL FDP will be an enriching experience for each one of you. Once again, welcome you all. Thank you.
Thank you, Deepa ma'am, for that warm welcome. Today marks a new beginning for all of you who have chosen to embark on this journey of learning and growth. This training program promises to equip you with the skills and knowledge you need to excel in the rapidly evolving field of cloud and edge computing. We are honored to have with us today Professor and the Head of the Department of Computer Science and Engineering at Adi Shankara Institute of Engineering and Technology, Dr. Ramani V, whose wisdom and guidance have been instrumental in the establishment of this program. Ma'am, I invite you to give us a brief introduction about the FTP.
Thank you, Parvati. So pleasant evening wishes to all gathered here on the special occasion of the ATAL online 6-day faculty development program on advancements in cloud and edge computing, research and industry perspective. The motive of this FDP, proposing this FDP is So as we see the algorithms in the advanced technologies, including AI, blockchain, then trusted systems, they are at least 2 to 3 decades old. So we have realized those processes, but we have to wait for the suitable infrastructure for for holding the data and processing. So it took 2 to 3 decades for us to realize it. So, for example, when we say language models, we have developed 2 to 3 decades, but we had to wait up to the for the last decade to develop large language models because we need to have the suitable cloud support. So with this understanding, and also we realized the recent placement scenario has changed. So the industries are looking for the students with potentiality in handling the cloud. We have been looking forward to develop such skills. Once the faculty develop skills, then only we can make our students put them in the right direction so that they'll get placed and participate in the growth of the country. So we, with the acknowledgement and gratitude to ATAL for sponsoring this FDP, so that we could approach the appropriate resource people for handling the sessions. The syllabus, the content for the 6 days being well designed, carefully all the intricacies of the contents are taken care well with the help of our coordinators. And we have approached the resource people, and they have consent to deliver the sessions. The day one today, so we have 2 sessions. Introduction to Cloud, Mr. Sutish N. Nair, the Senior Software Maintenance Engineer, Red Hat India Private Limited. And session 2, Cloud Virtualization, will be handled by Dr. P. Victor Paul, Assistant Professor, Department of CSC at IIIT Kottayam. Then day 2, tomorrow. So we have 2 sessions. Session 3, Database Services, Mr. Dharma Shivasamy, Senior Director, Software Engineer, Penske, United States. Then session 4, Serverless Computing, Mr. Joby Joseph, Cloud Technology Head, TCS. Then day 3, the session 5 is on Cloud in Research and Industry. Mr. Jacob Thomas, the Delivery Manager, TCS, will be delivering this session. Then session 6, Cloud in Education, will be handled by me, Dr. Ramani Professor in CSC at Adi Shankara. Then day 4, the session 7, which is on Cloud Edge Computing, that will be delivered by Dr. Rajesh Kedia, Assistant Professor in CSC, IIT Hyderabad. Then session 8 for computing, Mr. Hitendra Saxena, Lead Technologist, EY. Then day 5, session 9, IoT and ML, Dr. Ajay Kumar, the professor in ECE and is also head of AI IoT Research Center in Adi Shankara. Then session 10 is on Edge and IoT integration. Dr. Rakesh GK, Associate Dean Industry Relations and Fundings, IIIT Kottayam. And on day 6, session 11 is on Security in Cloud. That will be delivered by Anju JD, Cybersecurity Manager, EY. The session 12, Cybersecurity in Edge, Mr. Pawan Verma. So that will be handled by Mr. Pawan Verma, Cybersecurity Business Development Manager, TCS. Session 13 is on Edge, Cloud, and IoT integration. That will be handled by Mr. Jiva AKR, Global Leader, Azure Analytics, Global Strategical and Sales is a leader for it. Then he works in Microsoft, New York, US. So with this, the highly potential resources, so we are here to deploy this faculty development program. So we invite the faculty members who joined us for this development program, carefully attending these sessions and be interactive with the resource people, then participate in the learning process. Attendance is mandatory for all the sessions to get the certificate, as we all know, as per the ATAL norms. And attendance form will be shared in the WhatsApp group at the end of every day. So please take care to fill in that form to mark your attendance. So wishing you all the very best and have the enjoyable learning for the next 6 days. Thank you all.
A sincere thanks to Remini ma'am.
It is my honor to invite Dr. Meenakshi K, Director of Academics, Adi Shankara Institute of Engineering and Technology, a distinguished academic leader whose guidance and commitment to quality education have played a pivotal role in strengthening the academic framework of our institution. Her continuous support and vision inspire excellence in teaching and learning. Ma'am, it is our privilege to have you with us. I kindly invite you to address the gathering.
Yeah, thank you, Parvati. Respected HOD, colleagues, and dear participants, a very good evening to one and all. At the outset, let me congratulate the team of Computer Science and Engineering of Adi Shankara Institute for bringing the ATAL FDP to our college. As we all know, the AICT Training and Learning Academy, they call for FDPs every year, and it is a nationwide call, and all the colleges have the liberty to upload their proposals, and from among the various N number of proposals, we also got this particular FDP. That itself is a fact of pride for Adi Shankara, and it is the effort of the department, the coordinators who have taken all pains to see that all the topic is a potential topic, and also all the sessions are well curated of importance, and they have also taken all the efforts to bring down people from industry and academia. As the name of the FDP itself goes, it's advancements in cloud and edge computing in the research and industry perspective. So it is going to be beneficial to a wide range of audience, the academicians, the researchers. You're going to hear from stalwarts in the respective fields. And also you are going to get an experience of the people from the industry who are actually working on these fields. So for this, so whoever has joined as participants for this 6-day FDP, I'm sure that you're going to have a very good takeaway along these 6 days of various sessions. And as our HOD has pointed out, this is the need of the hour. This is the very potential topic where even students have to, when they are looking for the placements, they are looking for people who are able to work well in the cloud and handle the edge computing technologies. So as faculty members, it is only essential that we get equipped first and lead the students in the better way. And also for the researchers who are doing work in the latest topics, this is going to definitely help them. So I wish all of you could participate well in all the sessions, be interactive, take the maximum advantage of the experts who are coming there to deliver you with the various topics, interact with them, take the maximum out of them. And I sincerely wish the 6-day session all success, and wish that all of you have very fruitful days for the next 6 days during the evenings from 6 to 9. So all the very best to you, and all the kudos to the coordinators also Dr. Sridevi and Dr. Deepa, along with the HOD who have taken and also the whole of the CSE department who have put in their efforts to make this into a reality. Thank you.
Thank you, ma'am, for
you,
your
ma'am.
words of inspiration. It is my honor to introduce a driving force behind the research vision of Adi Shankara Institute of Engineering and Technology. Please join me in welcoming Dr. Sri Priya, the Dean of Research at Adi Shankara Institute of Engineering and Technology. With a deep commitment to academic excellence and innovation, Dr. Sri Priya has been instrumental in fostering a vibrant research culture within the institution. Her leadership has empowered faculty and students alike to pursue impactful research, secure prestigious grants, and contribute meaningfully to science and technology. Ma'am, it's my privilege to invite you to share your words of inspiration.
Thank you, madam, for the kind words. Respected Principal, Director Academics, Dr. Meenakshi ma'am, respected HOD, esteemed resource persons, and dear participants and my dear colleagues, a very good evening to one and all. It gives immense pleasure as Dean Research of Adi Shankara Institute of Engineering and Technology to be a part of this meaningful academic gathering today. So this occasion wherein we are about to learn more about computing, edge intelligence, data-driven systems, etc. See, I think that they are no longer optional domains. They are, in fact, now the foundation for modern engineering research and innovation. So the choice of the theme is very timely and strategically significant, especially from the research perspective. Because I think that throughout the upcoming sessions, several open and impactful problem statements will be discussed with you people so that for the engineering faculty who is participating in this FDP, you will get an opportunity to take up those as your research statement and work upon it to produce high quality publications and funded research proposals, etc. I'm particularly pleased that this FDP is bringing together experts from various organizations, premier academic institutions, so that the participants will get an exposure to various real world deployment of all these topics. So for the participants, for our faculty members, this program should be viewed not merely as a knowledge upgradation exercise, but it will be a platform to realign their research problem statements to match with the needs of the industry. So I would like to commend the Department of Computer Science and Engineering, the coordinators and the entire organizing team for curating such a wonderful, technically rigorous program. And also I would like to take an opportunity to express my gratitude to all the resource persons who have taken pain to participate, for sharing their expertise and interact with the faculty members who are participating in this FDP. So on behalf of Research Council, I request all the participants to interact with the resource persons, get a lot from their experience, expertise, use their expertise, interact with them, so that you will get some takeaway from this FTP, with the help of which you can guide the student community who is the builders of our nation. So on behalf of the Research Council and the institution, I once again congratulate Computer Science Department, the entire team, as well as I wish all the participants all the very best and wish FDP a great success. Thank you. Thank you.
Thank you, ma'am, for your words of inspiration. As we come to the close of this inaugural event, it's time to express our gratitude. I invite Ms. Sridevi R. Krishnan, Assistant Professor from the Department of Computer Science and Engineering, Adi Shankara Institute of Engineering and Technology, to extend a heartfelt vote of thanks to all who have made this day possible.
Good evening to all. Respected dignitaries, esteemed resource persons, dear faculty members and participants, on behalf of the Department of CSC of Adishankara Engineering College, it is my privilege to propose the vote of thanks for the inaugural session of the AICT sponsored ATAL FDP on advancements in cloud and edge computing, research and industry perspectives. At the outset, we express our sincere gratitude to AICT and ATAL Academy for sponsoring this FDP and for providing a funding to enhance the faculty competencies in emerging and relevant technical domain. We respectfully thank our Managing Trustee, Mr. Anand, for his leadership and continued support for academic excellence, and General Manager, Mr. Srikanth, for his consistent administrative guidance. We also thank our respected principal, Dr. Murali MS, and CTO, Mr. PVP Rajaraman. Our heartfelt gratitude goes to Ms. Dr. Meenakshi K, Director Academics, and Dr. Sripriya S, Dean Research, for joining this online inaugural session and providing their encouragement words. We sincerely appreciate the dedicated efforts of our HOD, Dr. Ramni Baibi, and who is the coordinator of this FDP, and the co-coordinator, Dr. Deepa Devasi, for their meticulous planning, leadership, and commitment in successfully organizing this program in virtual mode. We extend our sincere thanks to all resource persons for sharing their expertise and insight despite of their busy schedules, thereby enriching this FDP with both research and industry perspective. We also thank all the participants for their active presence and enthusiastic participation, which truly contribute the success of this online FDP. Finally, we acknowledge the efforts of the organizing committee, faculty members, team, and supporting staff for encouraging the smooth and effective conduct of this program through the online platform. Once again, thank you all for joining us. We look forward to the 6 days of productive learning, interaction, and collaboration. Thank you all.
Thank you, ma'am, for that gracious vote of thanks. With that, we conclude the formal part of the inauguration of the 6 days online FTP sponsored by ATAL on advancements in cloud and edge computing, research and industry perspectives, organized by the Department of Computer Science and Engineering at Adi Shankara Institute of Engineering and Technology. Thank you very much. We will be starting the first session shortly.
Mr. Sudesh N. Nair, are you there online? Am I audible to you, sir?
Yeah. Hi, Shani. Yeah. Okay. Can we get started?
So we'll just wait for 2 minutes.
Okay. Yeah.
Good evening, everyone. On behalf of the Department of Computer Science and Engineering, Adi Shankara Institute of Engineering and Technology, I warmly welcome you all to day one of the 6-day ATAL-sponsored online faculty development program on advancements in cloud and edge computing, research and industry perspectives. We begin today's first technical session with a topic that lays the foundation for modern computing infrastructures, Introduction to Cloud. It's my privilege to introduce our first resource person for the day, Mr. Sudhesh N. Nair, Senior Software Maintenance Engineer at Red Hat India Private Limited, with over 12 years of industry experience. He brings with him rich expertise in enterprise cloud technologies and practical insights from industry, which will be highly valuable for all the participants. Sir, we're delighted to have you with us. I kindly invite you to take over the session and enlighten us with your talk on Introduction to Cloud. Thank you, and over to you, sir.
Thank you, Shani, for the warm welcome. Good evening, everyone. And I would like to start by thanking all the dignitaries and coordinators and organizers for providing me with this opportunity. So let's begin the session with a question. So I hope we can make this session as much interactive as possible. So to start with, can everyone tell how many of you have used cloud today? You can use the raise button in your screen to raise your hand if you have used cloud today. Okay, 4 people. Only 4? We have around 84 participants, of which I can 4, 5. Okay. Okay, so how many of you have used WhatsApp today or Instagram Reel? Watch Instagram Reel. Or done an UPI transaction. So currently, if you have used any of these technologies, then you are using cloud behind. So all these technologies are currently deployed in cloud. Not just these technologies. Currently, we are conducting this session in a Microsoft Teams meeting. And I think, as you know, that Microsoft Teams meeting is, as a client, is also hosted in Microsoft Azure Cloud in a geographical location near us. And also there's a stat which states that approximately an average human being who interacts with technology of any kind, either using a mobile phone or internet, uses cloud at least 36 times a day. So in that regard, we almost all of us has used at least 36 to 40 times the cloud today. So even we are conducting this meeting over cloud technology. So to start with, before going into what's cloud computing, its infrastructure architect, different deployment models, and service model advanced concept, and we would also be covering the future trends in this technology. Before going into this agenda, I just want to take a few minutes to discuss why exactly are we discussing cloud. So I think our honorary dignitaries has already explained that why they choose cloud and edge technology as a topic for this FDP program. But exactly, I just wanted to share you with few statistics data. Why cloud? Basically, because today, if you ask anybody, the buzzword is AI or ML. If you ask anyone related to IT or computers field, what they are interested in, what they are working on, no one has to say anything outside AI, ML related topics. So to go little outside this buzzword and choose a FDP topic for cloud computing edge technologies, I would like to really give an applause to the organizer. That's something brilliant thought process. Okay, can anybody guess that what's the market share of cloud as of 2025? Okay, I'm shared my screen. Are you able to see it? Just confirm it.
Yes, sir, we can see it.
Okay, so yeah, can anyone, you can type in chat or unmute and say, give me a guess, random guess, what would be the market share? It's in dollars of cloud computing. Maybe in background, you can ask chat GPT or Google it. Any random guesses? Okay, so basically the cloud computing is estimated to be around 900 billion US dollars market share as of 2025. So basically 900 billion, if you consider it as a GDP of a nation, cloud computing comes as around 15th biggest nation in nominal GDP terms. So it's even richer than some countries like Belgium, Israel, etc. And it's been estimated to cross 1 trillion in the first quarter of 2026 itself. So $1 trillion industry. So you can estimate how big this industry and how big this opportunity is there. And by the year 2054, it's been predicted to cross around 5 trillion US dollars. The cloud computing industry itself. And it's growing at a CAGR of 15 to 21% currently. Just to give a perspective, if you have invested in mutual fund or stock market in India, with one of the fastest growing economics and stock market in the world, you would be getting a returns of around 12 to 13%. But on the contrary, someone who is investing in cloud computing is expected to grow around 15 to 21% rate, the compounded annual growth rate. So it will cross 5 trillion by 2054. So basically, it would be competing with the big five economies like US, China, India, Japan, etc. In next 20 to 30 years, just the market share of the cloud computing. And also currently, although currently the 52% of this cloud computing market share comes from North America, but it's been recognized that Asia Pacific is currently one of the highest growing market for cloud computing as well. So anyone who is working in India and Kerala, so you know that more in Kochi itself, we have lots of cloud networking underwater cables being put here. So one of the major cloud underwater infra center is located in Kochi with this network cables and infra resources. And considering that Asia Pacific is growing fast and China and India being one of the major nations as part of this Asia Pacific growth wagon, we should expect that lots of our industries would be going to cloud. Just to give you a backstory, when I started with, currently working as a senior software maintenance engineer in cloud native development pillar of Red Hat India Limited. Red Hat specializes on basically cloud and containerized products and technologies, starting from Linux, RHEL Linux to OpenJDK, to almost all the softwares which you have used in your cloud area. Red Hat almost ships most of them. And it's an open source based company, which means that most of our source code of the products that we ship is open source and free to access for anybody. But I started with Infosys as a Java developer. And when I started as my first project in a healthcare system, it was completely on-premise data center. Basically, all the applications were hosted in the on-premise servers of the client. But during it's I think around 2014-15 time. When the company had first started planning to move to cloud. Basically, it was during that time the cloud was the buzzword. Basically, currently as AI is now, at that time it was cloud. And almost all industries and all the applications were discussing about should we move to cloud, why should we move to the cloud. Even our applications also, we had created designs, architects around how to move it to cloud and everything. So it's, I think, only been around 10 years since the development of cloud as a mainstream environment or methodology. To give a background, IBM had first introduced the concept of virtualization in 1965. That was the first time when a concept of resource sharing was introduced, where networking details and all those can be shared as part of virtualization. That was in 1965. But AWS, the Amazon Web Service, which was the early mover in the cloud space, they started around 2006. And the most of the cloud orchestra engine like Docker and Kubernetes only started around 2013 and 14. So considering that it's a really nascent industry, only just decade long, and it's almost reaching a $1 trillion and expected to cross 5 trillion in next 20 years. So yeah, you can just imagine the opportunities and everything. When I started, cloud was just an option or a choice, but now it's no more an option. It's a mandate. Which cloud, how to configure in the cloud, all those can be discussed and detailed, but cloud has become a de facto standard for application development and deployment in nowadays world. So when I talk about modern day, so why exactly was cloud introduced? So previously, when a developer used to work with any kind of technology or applications, the developer's concern was only writing the code to make that application work. Whatever is the functional or non-functional requirements, they just have to satisfy that and write a code to implement it, ensuring the performance, reliability, and scalability. They were never concerned about where this application has been deployed and how this has been deployed, how it will scale, how it will be moved. All those infra things were not considered. We used to have system administrators. Then we had operations heads, everything. You used to look after all the infra and operations parts of the thing. But as the development become more and more complex and speed to the market increased, the time that developer had to deliver a product reduced a lot. Previously, there were application coming out only on 6 months to 1 year basis. Now you have app release almost fortnightly. So with such fast process, it was no longer reliable for the developer to just think about the code. They had to think about lots of things. How it will scale, how many users it would be using, where it would be deployed, how it would be deployed, and how it could be managed after post deployment, how it would be maintained. So now it's not just about code. So application development has become far more complicated, and they have to consider the complex environment in which they have been running. So that's when the concept of cloud came back. So whenever there is a talk about cloud, exactly. So what exactly is the cloud? So I think almost everyone would have used cloud storage. You would be knowing that all our data, all the apps which we use in our phone nowadays, the data is now they provide an option to store it in cloud. Even if you see the Google Drive, Gmail, everything, the data is being stored in cloud. So exactly where exactly is this file residing when we say that in the cloud? Any answers? Any? So anyone can tell what exactly is and where exactly is this cloud residing?
From where you purchase the cloud, the owner maybe AWS or something else.
Yeah,
Which company you buy, then server will hold your data
okay.
or
So,
programs.
so what exactly that company provides you with?
Depends on user requirement. Right? Suppose you want IAS or PAS or SAS, whatever you want, for which he has to pay and use it.
Okay, yeah, that's good. So basically, when I talk about cloud, basically, so this was one of my, sorry, a recent experience, not just recent, I think last April. So we are always, every year we onboard lots of new team members and we just have to train them and mentor them. And so as I was mentoring a new team member who is just fresh out of the college, and we were just starting the orientation and everything, what's cloud native department development and what's happening. I was just asking him, what do you know about cloud? What's cloud native development? Uh, so when I asked him what's cloud, basically, the answer I got is basically cloud is someone else's computer. I think almost all of you have heard this term. What's cloud? Basically, it basically someone else's computer. Although it's technically correct, maybe I would say that partially correct. It can be someone else's computer. But in order for a person's computer to become a cloud, it needs to fulfill few criteria, basically. So yeah, to start with, it's correct that for cloud also you need an hardware, infrastructure or a server, which is residing at some location. It can be in a remote location across geography, or it can be a local location, maybe near to you, or even it can be on premise in your industry or company itself. But there needs to be have a physical infrastructure for a cloud to perform. But on top of that, when we talk about cloud, we are not talking about any specific technology here. Cloud is an environment. So cloud is not a technology or a software or anything which is provided by a third-party provider. It's basically an environment where we can deploy our functions or applications and software as a workload. So basically, cloud would be an environment, and cloud computing is the act of running our workload on the cloud. And we use lots of technologies and tools in order to build and achieve this, the act of cloud computing. So we must first understand the difference between these three terms, although in generic terms, we use them in interchangeably, but technologies and tools we use to build and deploy applications in the cloud environments to ensure the act of running those workloads. And how is it different from virtualization? So there is also lots of confusion, like virtualization and cloud are somewhat similar, or some consider them same. As mentioned, virtualization is a technology, but cloud computing is generally a act or a method of performing that act. It's a methodology. So cloud computing is an abstract term where how you design and how you architect, you have lots of flexibility, but you need to just satisfy with criteria. Whereas virtualization is a technology which enables you to share a physical resource with multiple people. So for example, if you have a single hardware server, you can divide them into multiple small resources, virtual infra resources, and share it with multiple people using virtualization. Whereas cloud computing is an environment that uses pools of this virtualized resource, but it should enable these few criteria. One would be ease of use. So cloud, the physical server or the infrastructure which has been provided by the cloud should have the flexibility to ease of use. Basically, so anyone who is using AWS or Google Cloud, they would be knowing that you just have to log into a web URL, create an account, and get yourself assigned a cloud instance and use it. As said, we can use different models on how the payment and the cost works. But the second criteria would be reliability. Although it's a virtual resource which is been assigned, we need to ensure that that's reliable across all conditions. And if it's something like that, your app is deployed today, but evening you don't know what happened to that app, then basically that's not a cloud resource. And third would be interoperability. With the cloud, you should be able to interoperate or move that application from one cloud to another, or one architecture to another, or one system to another easily. There should be option for that. And the last, but the most major one would be scalability. So if you know that if you know about Netflix, around in 2010, when Netflix started as a company which would ship DVDs to their customers. So it's basically you can rent a movie on Netflix, but if you rent a movie on Netflix, what they do is that they ship you the DVD to your location. You can watch them. Once you have watched it, you should have to ship it back in a prepaid envelope. They would share you a prepaid envelope. You just have to ship it back. So that was the how Netflix began. Then they moved into streaming services. But when they started with the streaming services, everything was hosted in an on-premise environment. But around 2013-14, they took a decision to move almost all their data to public cloud. So during that time, there were lots of talk around this in the industries. How risky is that, and how well can it go, or what can happen with this move? Because Netflix had lots of movie and lots of data. So moving this data to a public cloud, at that time, no one was sure how that will turn out. But when the Squid Game, if you have heard about the Squid Game series, one of the most popular series in Netflix, I think till date it's one of the most watched series in any streaming platform. When it was first introduced, there were around estimated 1 crore to 10 crore hits in a few seconds to that particular show. So in order to handle such a big load, if the streaming platform was deployed on an on-premise environment, then it would have collapsed within seconds. I think few of the members few of us who already were there when the first Big Billion Day sale happened in Amazon. Do you remember, any one of you? First Big Billion Days when Amazon happened. At that time, I think there were offers like 1 rupees, etc. There were offers of 1 rupees, and so at that time, you may have experienced that there were lots of there were lots of issues with the server being going down and everything. And it's ironic to know that Amazon was the pioneer in cloud computing. AWS was one of the first movers in cloud space, but still when Amazon launched a big billion sale, their servers crashed. But Netflix was smart enough that when they had to handle such a big load, they were able to do it. The major reason was the movement to public cloud. Okay, so when we talk about public cloud, exactly what is that we are talking about? What's the blueprint of a cloud? So basically, any cloud system that or cloud environment or methodology is created on the basis of two components. As with building any house plans, you need materials and you need a blueprint of the plan, actual how the house would design. So nowadays you have lots of plans. If you have recently built any home, you would be knowing that it's just not the floor design or anything. You would be having 3D diagram, virtual reality of how your house look, interior design plan, piping design plan, electrical plans, lots of plans. Sorry. So similarly, with cloud also, it's made up of two components that we call, one is infra and other would be the architecture. So cloud infrastructure incorporates all materials while the cloud architecture is the blueprint. So what's the infra in cloud's term? Basically, all the servers, the networking components, storage, and all the physical things that is used to build the actual server or the storage space is the infra for any cloud systems. So in generic term, in industry, we talk about it as like bare metal systems. So bare metal system is a simple infra system which you don't have anything on top of it. You can configure as you want. So that's the foundation of any cloud infrastructure. Then when we talk about cloud architecture, so architecture is how about the cloud. So basically there are infinite number of permutation and combination on the basis of which a cloud system can be built. There are major models and major services types related to the cloud. But as per the business requirement of the industry where the cloud is deployed, we need to manage how this particular architecture is developed. So, for example, if you are having a healthcare system, so that architecture may be completely different from a website which sells clothes. So both are developing an application, both needs to be deployed in a cloud environment, but both architecture would be completely different. So even with old architectures before microservices like monolithic and everything, we always used to have 3 different layers like front end, middleware, and back end databases. Even with cloud architecture also, we use these layers. We use virtualization on top of infra to manage all this. But the architecture model depends on which type of cloud we are using. So these are the 4 basic architecture blueprints which can be used: public, private, hybrid, and multi-cloud. Just go one by one. So it's basically like buying a property in your neighborhood. So while buying a property, there are having a house, you have multiple options. The first option would be to rent a apartment in a building. So that's like a public cloud where you are just renting out the infrastructure. That infra is owned by some cloud provider, a third-party vendor, which we call as cloud provider. And we use it as per our requirement. And once we don't have the requirement, we release it. They share the same infra to someone else owns it. So basically in public clouds, what happens is that the cost and the time to switching and setup would be very fast, considering that you can just create a login ID, you can start getting how much resource you want. You can just tell the configuration, like from T2 micro or EC2 instance, whatever you need. You can just rent it out, start using it, deploy your application, and move forward. And but the actual application or infra is managed by the vendor. So with this, one of the advantage is that scalability. So it's basically cost is as you use kind of model, where how much you use, that much would be the cost. So you have option to scale as per your requirement. So there is lots of orchestrations and automation tool like HPA tools, which help you scale the infra as per your load requirements. So as for example, today, now for next 2 weeks, there is a big billion day and have a huge load requirement. I can scale up the servers. But in on-premise time, we used to have 400 to 500 servers created for that purpose. But what happens after the 2 weeks when that load comes down? What will that 400, 500 servers sitting idle do? Just wasting your cost and finance. So with public cloud, that's the advantage. You can scale up and scale down as per your requirement. And second type is private cloud. It's like buying your own house. So private cloud, you are the owner of that particular cloud infrastructure, and you have the complete control and accessibility over that. It will be inside your own firewall. So you can control the access restriction as per your requirement. Obviously, the cost would be higher, and even the time to set up would be also higher, basically. So this can be used when you are using a high security environment like banking, insurance provider, where your data is very critical to you. You don't want to share it in public cloud or anything. So private cloud can be used in such scenarios. And third is hybrid. So hybrid is a combination of private and public cloud. So nowadays, no one just relies on public cloud or private cloud. Any big organization which has their apps or workloads deployed on the cloud use a combination of private and public clouds, which is connected through a network. So private, where the private cloud is used, it's like I have few data or confidential information which I don't want to share anything outside my own infra network. I need it completely under my control. For example, banking details or customer health insurance detail, personal information details. So I can keep those data in the private cloud, and generic websites and web applications related to your app that can be hosted on a public cloud, which can be easily scaled up and scaled down. So basically, private cloud have a separate VPN connection, separate security systems and everything, whereas public cloud would be easily accessible, and depending upon this, your cost can also be managed to a large extent. And fourth one is multi-cloud. So multi-cloud is kind of an expanded version of hybrid cloud, where hybrid cloud is a combination of private and public cloud. In case of multi-cloud can have clouds from different vendors. So it's a system where you have some applications are deployed on AWS, some deployed on Google Cloud, some on Azure, some on public cloud, some on private cloud. Some may be a managed service instance of the cloud, some may be a dedicated service instance. So it can have all those permutation combination. And for multi-cloud, it's not necessary that they are integrated. It can be hosting a completely different application on completely different cloud. So for example, any customer facing application, they may be deploying on a one cloud, maybe internal application, which is only used for internal business purpose, that may be deployed on a different cloud. So next question would be, when we have different types of cloud, what are the different features available and where to choose it? Basically, as I told, public cloud is owned by the provider, whereas private cloud is owned by you. So public cloud is multi-tenant, so there is a issue when it comes to network latency and security, whereas private cloud is single tenant instance, but it will have necessary cost associated with it. Even scalability is also an issue beyond a program, a set value. Then hybrid cloud is a mix and match of both. So depending upon your use case, for example, I am a normal guy, I want to start a web-based or internet-based company. So I won't be setting up a private cloud and investing lots of infra. Maybe around 10 years back, I had to do that. I had to create a server, or maybe you hire a vendor who could do it for me, which was a huge cost. But now I don't have to do that. I just have to log into AWS or Google Cloud or Azure or any cloud platform. I just create an account, and as per my requirement, I can rent it out in public cloud and use it. But if you are a big banking organization or a healthcare insurance organization and everything, you may need a very large infrastructure. So which may include private cloud and public cloud, a combination of multi-cloud and hybrid cloud environments. So next would be service model. So just going before service model, if anyone has any questions. Any doubts, any inputs or anything?
I have a small doubt, rather a comment, that you mentioned the architecture or blueprint different from infrastructure.
Yeah.
Right?
Yeah.
But when my understanding is blueprint will be or any plan, maybe civil work or infrastructure, as you said, bridge construction, building constructions, whatever you make a approved copy is a blueprint. It will be is a traditional style, but when you say blueprint only for the architecture, it's a little bit of confusion rather than clarity.
So in computing term, we call it as cloud architecture. So in generic, as you told in civil area, what we call is blueprint is a plan that we create before creating any kind of civil constructions, like, right?
Yes,
so
right.
any plan that we create and document it and get it approved, that would be the blueprint of that plan. And in cloud environment, when we in generic term, when you go to any industry with the cloud, what we call, there will be designation called cloud architect and cloud architecture design. So basically the job of this particular person is to design the cloud architecture. So that's the term used in IT industries for this purpose. So in civil industry, what we generically normally call as blueprint, while doing the construction, the diagrams and everything. In computer terms, see, it's a like an analogy, like cloud architecture. That's what we call. So these are all abstract terms. It's not real definition. So,
but in general meaning, infrastructure refer to road or rails or extra which are connected to the your factory or connected to your company. That is called infrastructure. That's what my understanding.
So infrastructure is basically whatever resource you need to develop that particular entity, whatever may be the entity. That's the infrastructure you need. So for example, if I have for example, Infosys Mysore campus, if you say the infrastructure of Infosys Mysore campus, they have around 10 to 15 global education center buildings. There are around 3 to 5 technology development center buildings. They have around 4 to 5 food courts. So when you look up the infrastructure of Infosys Mysore, that's what the infrastructure which we developed. So basically, in cloud computing term, what we call as infra would be the physical servers, the storage networks, or the networking components which is there as a means physically available for creating this cloud. That would be the infra for the cloud.
Okay, thank you, sir.
Any other questions? Okay. We don't have any other questions. Let's continue. Okay. So basically, next topic is service model. So as we discussed about the architecture and types of architecture models, or the main pillars that we have for cloud, like public, private, and there is another way which evolved when the cloud computing system came into picture. So this is called as a service model. So before the introduction of cloud, or during the era of monolithic architecture, if you had to build so for example, to give you an analogy, if I had to build a biryani shop, what I had to do is that I had to buy a land, construct the restaurant, buy all the equipments, hire a chef, buy all the ingredients required, then do the inauguration. Then Only after all this background work, then only I can actually start cooking biryani and sell them. So even before starting the selling process of that biryani, I had to invest a lot beforehand in order to get it set up. That was the era of on-premise computing before the arrival of cloud. So basically, it was like capital intensive kind of investment. You had capex, lots of capital invested even before you sell your first biryani. So even once you sell the biryani, if no one likes it and you go in loss, all the capital investment that you had is on loss basically. But with the invention of cloud computing, they came up with a model called as a service, where all as per your requirement, the required components were provided to you as a service. So there were different levels of services being provided to you. So basically, you could just like building a house, you could either just buy a land and build a house, or you can buy a normal house without any furnishing or interior, or you can also buy a fully furnished house ready to move in. So basically, these are just an analogy to different types of services models available. So these are the three layers of services available. First would be infrastructure as a service, where you would be only sharing your hardware. So the service provider would be only providing you with the infrastructure, which is the hardware. So infra as a service means the hardware components would be provided you as a service, and this would be owned by the vendor, maintained by the vendor. You just use it to build on top of it. So you would be installing your own OS system, if it's containerization or virtualization, whatever is, you would be doing that. Then on the top of that, you would be building and deploying your applications. So it's basically like you have an hardware on the basis of a operating system, which should execute all the runtimes. Then in order to application specific runtime environment would be there. So for example, if it's a Java, you need a JDK, JRE. If it's a Python, you need a Python libraries, pips installed for that. And all the related softwares and everything on top of that. Then on top of that, you need the application runtimes or so-called servers or to execute the applications. So this was IaaS. Then there came a next level, which is platform as a service. So in platform as a service, they would used to ship you the entire platform to you. You just take care of your application. So platform is hardware plus the operating system part. So the platform would be like, for example, if you're buying a laptop with pre-installed Windows or Linux, it's basically they are giving you a platform. This is not as a service, you're buying it, but in case of cloud, you would be renting it out as a platform. You just take care of application. And the next level would be software as a service. So software as a service, they would be just shipping you a software. You can it can be a desktop-based software or a web-based software, depending upon which type of software is that. You just have to access it and use it. For example, Gmail is a software as a service. Salesforce, if you have used it, that's a software as a service. The Google Docs, these are all software as service implementations that we use. So from the market share point of view, SaaS is the most convenient and is has the highest number of market share, most used one, where the provider manages everything. You just take care about your work, the actual your utility or function that you need to do. You just do that. But if you need more control, then you should go below to platform or infra level. So as you go higher up the level, you release the control for convenience. So depending upon your architecture, you can pick the service. So nowadays there is a latest one more service which came up, which is called as function as a service. So if you have recently worked with, any of you have worked with any serverless kind of technologies? Any idea about that? What is serverless? Till now, everything that we talked about are everything servers being deployed on cloud. when we talk about function as a service, we are talking about a serverless kind of service. So when I say that serverless, it's not like there is no server. What it means is that you don't have to worry about the server. You only worry about, so in software of service, entire software would be shipped to you. Here, the only a function that you need would be shipped. Basically, if you are using a Lambda, anyone use Lambda? You just raise your hand in the chat if you have used it. Okay. So yeah, so that's an example of function as a service, basically, where it will be triggered on event basis, event-driven functionalities, majorly used by JMS or messaging services like Kafka and other JMS providers. That's that kind of functionality, widely used function as a service. It is basically, it will be triggered on a scheduled event. When so and so event happens, you need to trigger a function, or when a API is called, you need to trigger a function. So that kind of function happens. So all the serverless functions act as an ephemeral functions. So basically, there won't be any persistent data anywhere. It will execute what it needs to be executed. It will return the output. Then it would be stateless. So the state of that particular execution won't be maintained anywhere or persisted anywhere. That's basically it's a advanced version of software as a service, but far more comprised, and it's completely works on serverless function. So just to combine everything, when we talk about a cloud landscape, it consists of two things, basically, majorly infra and architecture. Infra is the actual resources or the physical resources which is required. Then architecture is the main part where how you create the cloud depends, and it majorly depends upon the types of model you select. It can be public, private, hybrid, or multi-cloud, and what type of services that you use. So as I told, if it's a IA service, you would be managing all the physical layer, and all the software kind of layer would be application, including operating system, would be managed by you. The rest will be managed by the provider. For platform as a service, you would be only managing your application and its data. All other platform would be actually provided to you by the vendor. For SaaS, you don't have to manage anything. Everything would be provided by the vendor itself. For FaaS as well, it's the similar concept, but here it will be providing you with a serverless functions like Lambda. So in real world, this is how the architecture would be, look like. You would be having different layers, starting from physical layer, then there would be abstraction layer, and at the top there would be orchestration layer. But what's mainly it's done, all this everything efforts that's been put is been to ensure that the developer just focus on the actual implementation or the functionality they need to develop, not to worry about how it is managed at the back end and all these boilerplate things. But as you say, cloud computing was introduced for, there's a saying, I think, the cloud computing was introduced for simplicity. So in nowadays also there's a major question you may get asked by any new engineer, freshers, or even with the coming of AI, basically. I think every one of you, or even I, get asked multiple times, at least a week, that what happened to your job, because AI is going to take over everything, it's going to do everything. So this kind of buzz was also there when cloud was initially done, especially for the system admins kind of operations kind of guy, because with cloud was managed to automate and simplify everything, that what would the system administrator or a operations guy would do? So this kind of questions is to arise then. Maybe that's why they build something called as Kubernetes. And Kubernetes is something which ensures the job security for all the system administrator and operation guys. Because in theoretical terms, cloud simplifies everything. But as I explained to you, the real world scenario is so real world scenario is pretty much complex. You need to manage all the systems which is deployed in the cloud, and it's not humanly possible to manage when this system turns so complex that from 10 servers which we used earlier, now there are 1,000, 10,000, maybe even lakhs of servers being run at a time. Even just to start this number of servers, it's not humanly possible. You may have to hire at least 10 engineers for 1,000 servers at least. That's not humanly possible. So with cloud computing, most of the companies or leadership of the companies, 75% of them, they complain mainly the complexity of this cloud computing infrastructure, how they handle this, and the cost wastage due to this complexity is causing major issue for them. So this is how a real world cloud architecture system would look like. So when you log into a Netflix account or a Amazon Prime website, or even Amazon shopping website, in background there would be a complex architecture which maintains all the interaction between each and every functions, and it would be having thousands of servers, data centers located across geographical locations, different kinds of application deployed on different technologies interacting with each other. So in order to manage this in cloud, become really a headache. So for that, we needed to have a cloud management system. That's what something called as cloud orchestration. So in 2013, Docker came up as a containerization platform where anything and everything can be converted into a container and deployed basically on the go to the cloud environment. And in 2014, Kubernetes was published as an open source project. So it was based on Google's in-house project, which they developed for around 10 years before that, something called Borg or something. Based on that project, Kubernetes was developed, but they provided it as, donated it as an open source project. Currently, anyone can access it. And 10 years from now, Kubernetes is considered as the de facto standard for cloud orchestration platform. And there are many other platforms which is built on top of Kubernetes, like OpenShift and different other platforms. But all these are made on top of the Kubernetes standards which has been defined. And in 2015, there was a foundation formed called as Cloud Native Computing Foundation, which is managing and maintaining all these open source projects related to cloud orchestration and DevOps technologies. So when we talk about orchestration, it's not just automation. So in generic term, automation, what does automation means? Automation is a concept of what you call it, it's a concept of removing human intervention from doing a task. So basically, if you have to start a server, normally with a human interaction, you run a command. Human would running opening a terminal, running a command to start a server. When you are saying that I'm automating it, my intention is that that should run without any human assistance. I don't have to run a script or anything in background to achieve the complete automation. But what orchestration is happening is that in this complex environment where we have thousands of functions or workloads interacting with each other, I need to ensure that all these particular systems are interacted and maintained in proper logical orders. So in order to orchestrate the interaction between these individual components, we need a tool which should do that particular. So for example, if the order is first start a server, then deploy a application, then open the traffic for the user, uh, then monitor the CPU usage for those traffics, and depending upon the CPU usage, scale up or scale down the required infrastructure, or in generic term, the number of pods or instances used. So if you want to do all this thing, automating individual tasks won't be enough. You would need a tool which would do this sequentially and ensure that the previous task is successful before doing the other task, and maintain that orchestration. And maybe this particular task may be performed in a different cloud location, and maybe deployed using a different technology. So itself, so the cloud should be capable, the tool should be capable of handling all these things. So that's where orchestration came. So in simple terms, if automation is a musician who would be playing violin, flute. So there are, in a song composition, there would be lots of musicians. One would be a singer. There would be lots of drum artists, violin players, guitarists, depending upon the composition. But there need to have a conductor who ensures that everything is played according to the musical note which has been composed by the director. That's the purpose of the conductor, to ensure that everything flows in a specific order so that music comes out perfectly as the director had composed. In this case, the director would be the architect who created this architecture, how he designed or envisioned it. The orchestra needs to be programmed or configured so that it's been executed like that. So orchestration is the conductor here who coordinates everything and ensures everything is executed properly. Okay, so next is manage cloud services. So before going to that, just 2 minutes. Anyone has any questions? Anything to discuss till now? Anyone over here who has a AWS, Google, or Azure account? Anybody logged in using it?
I want to just ask on functional call.
Yeah, function as a service.
Yeah, is it like in Python we will call import TensorFlow as a TF, import pandas as a PD, and import NumPy? These are all functions only. Is it similar to that?
Theoretically and conceptually, yeah, it's similar. So basically, in generic coding term, what we call as a function is a set of code block which is being written to execute a specific output. So basically, it should do only one thing. So it's like single user principle. If you learned about solid principles in coding, there's a single user concept. So every function that's written should only do one task. So that's the basic definition of a function. So similarly, when we call it function as a service, even that function which is provided would be doing, should be ideally, not in all real world scenario it would be doing that, but ideally it should be doing a single task. That task can be anything. So for example, if you are using an edge type of system, so a IoT platform, basically, so in that there would be some broadcasting happening. So for example, in a WhatsApp group, you are sending a message to a group basically. When you are sending a message to an individual, it's a one-to-one communication. But when you're sending a message in a group, it would be a broadcast kind of communication. It's not necessary that all the users in that group would be online at the same time when you're sending it. Some may be logging in after one day, maybe after 5 hours, 6 hours. But the message needs to be seen to them when they access that group. So these all are kind of simple functions which can be triggered on the basis of events. So these are events which is happening when a message is sent, and it can be configured as. So it's not necessary that it function as a service is the only way, but this should be most what you call resource effective way to do it, in the sense you don't have much of a overload. Basically, you don't have to worry about how everything in the background works. You tell him that broadcast this message, it will broadcast that message to whatever topic you have been subscribed to, and how it does, that's been handled in the backend by the serverless logic which executes it. Anything else? Okay, yeah. As I was discussing, does anyone has AWS, Google, or Azure account? Have anybody has ever assigned a EC2 instance, or maybe T2 micro kind of instance? Anything work with cloud? Any application deployed? Okay, so just from computing perspective, do you know means how much resource is required to run a kind of T2 micro instance in a cloud environment? Micro is basically one of the smallest kind of instance which is available in cloud. We have micro, mini, major. So it basically depends upon the number of CPUs available in the instance, or the memory and storage, etc., available in the instance. So micro, you can consider it as one of the smallest available instances. Any idea how much? Any random guess? How much resource that use? So just share your fact about that. So basically, the amount of resource used by a T2 micro kind of instance is equivalent to the entire resource used by Apollo 11 mission, the computer system behind that mission. You used to launch the rocket. So basically, the NASA had one of the pioneers who developed computing systems, basically for their development purpose. So what was a resource that used by the Apollo mission for the computing purpose? Almost that much resource is used by a T2 micro instances. And yeah, so from that point to this point, so for example, that particular computer instance would be, if you have seen older videos or images in YouTube, that particular server room itself, it's called the actual server room, because that computer itself, you could get inside that computer or a server, and you can just plug out and plug in the hardware components. It was such a big. Whereas the T2 instance, micro instance is so small, and it's basically cost would be around point would be, it would be free, few cents per hour kind of a costing technology. So that's how much as the cloud computing system has transformed the industry, basically from the accessibility point and the cost point. Even just to give you another example, any idea how many videos get uploaded to YouTube per hour basis? Sorry, per second basis? It's been estimated that around every minute there are around 500 hours of content being uploaded to YouTube. So if you're using YouTube streaming platform, not for streaming purpose, not the amount of YouTube video being watched, it's the amount of YouTube content being uploaded every minute. And every day it's estimated that the 82 years of content. So basically, the now amount of content get up and uploaded to YouTube in one day. If you have to watch it, it would take 82 years. So 82 years worth of content is getting uploaded to YouTube every day. Still, when we log into we in web browser, we go to YouTube and access any video. Anyone have observed any kind of latency or lag in that, apart from the issue with your own internet? Have you ever observed that you from YouTube and such kind of latency? Just imagine that if YouTube had to create such a huge infra system to handle such huge components or maybe storage capacity for the videos in an on-premise system, which was earlier available, how much it would cost, how much it would cost, how much it would effort would it take, how much human being it would have taken to maintain it. But with the cloud computing, it would have just take even fraction of the cost which is required by the on-premise installation. So that's where the cloud becomes, as I started the session, cloud becomes a mandate nowadays, not a option or a choice. And when we go into cloud services, we already discussed about infrastructure as a service, platform as a service, and software as a service, which is also as an extension called function as a service. Apart from that, she told there is something called as managed cloud services. So there are vendors which do all the manage, even for all this system. For example, if you are using infrastructure as a service or a platform as a service, or you have a hybrid model, in most cases, you may not be, as a company, you may not be having or you may not be having enough investment or enough manpower to hire and maintain the complete cloud service, even with those orchestration tools and everything. So even if you're able to install, maintain and everything, it's a huge effort. So there comes the concept of managed cloud services. What here they does is that the third party vendors in this kind of scenarios, they manages the entire cloud for you. So it may be a private and dedicated cloud that you own, but it gets managed by the third party vendor. Or it may be a hybrid cloud with a IaaS system. But in this case also, it would be managed by some other third party vendor. It can be a cloud provider, it can be orchestration tool provider, or any other third party companies. What it enables is that the cost for setting it up, one advantage is would be the knowledge. Basically, the person, since they would be handling lots of cloud services, the technology and the persons they have would be far more knowledgeable than the person you would be having this in your company. And second would be obviously the cost related to that. Third would be reliability. So managing this kind of infra network, you don't need to worry about whether the cloud, what happens if the infra goes down, because that's been someone else has provided and agreed a contract to ensure the that it remains up for a specific reliability amount time. So this is the another model which has which is called managed cloud services, which can be availed on top of any of these models. And most of the cloud-based industries normally uses managed cloud services. And next, we would be going in discussing about future of the cloud computing technologies. So as I just told you, in the first half of 2026, not just the first half, even by the first quarter itself, the market share of cloud computing is expected to hit around $1 trillion. You know that how huge is that, and obviously it's been almost 2/3 of this market share is controlled by the big three. Okay, any three? Guess which are these big threes when it comes to cloud computing? Any idea who is the biggest player in cloud computing industry? Can type it out in chat if you don't want to unmute and speak. Everyone slept off? Okay, I got one ping. AWS, okay. Any other? Okay, I'm not sure if we have an option to add a poll to it. No, I don't think I have it. So how many of think it's Google, the top player? Just raise your hand. Don't sleep off. This is how I think my manager feels when no one talks in his meeting, in our company's meeting. There are 68 people right now. Only one person had raised the hand. Saying for Google. For Google, only one. Okay. Okay, 3 for Google, 4. And for AWS, how many? Can just drop your hand and raise again. Your thing AWS. For AWS, 2, 3. Okay. And how many of you think Azure? AWS people can drop your hand, and anyone who thinking Azure. Sure, around 4. Okay. The leading player for cloud computing is AWS. It has around 30+% share, followed by Azure, and Google is at the 3rd place. So, and together these big three controls around 60%, 60 to 65% of the market share for cloud computing. Now, when we talk about the future about cloud computing technology, as per the recent research and predictions that been around in the different research industries and panels, it's considered that these 4 pillars is going to be the main, what you call, main components which would be detecting the market share or how the cloud, whose cloud would be in at the top. Although AWS is considered to be the highest from the market share, both Azure and Google has a higher growth rate compared to AWS. So the way they are growing at a faster pace. Google has a huge advantage of data analytics. They have a huge Gemini back system, whereas Azure has a huge advantage of enterprise software system. And obviously AWS was the first mover in this category. That's why they're still leading. But the growth in future would depend who going to adapt on these 4 components or technologies going forward. So first would be, as everyone knows, it's AI era right now. Everything is about AI, ML, Gen AI, agentic AI, RAG, everything. So anyone speaking about computer nowadays talks about AI. So are these cloud computing or cloud providers or vendors how they are able to scale when the workloads which needs to be deployed in the cloud is AI workloads. So anyone would be knowing that AI workload is far more resource intensive compared to the older or normal application workloads. When we talk about normal servers, we talk in terms of CPUs, but when we talk about AI workloads, we talk in terms of GPUs, and it has lots of computing resources required. And the complete technology and architecture required for running the AI workload is completely different, basically. So are these cloud providers providing the cloud which is AI native? So when I started, as I told, I worked initially with on-premise, then I had worked also migrating to cloud environment as well. But when we started migrating to cloud environment, what we called was cloud-ready applications, because it was initially developed for on-premise environment. Then we were adapting it to cloud, so it was cloud-ready applications. Now the pillar that I worked in Red Hat, it's called cloud native development. So all the application or tools that we develop is basically cloud native. It's basically natively developed for a cloud environment. But next would be all the application and infra would be AI native. Are they cloud environments which has been provided, are they AI native? That's the next big question. If it's that, then it would be, they would be having huge advantage going forward. And the second pillar is basically edge computing. Maybe even till 3-4 years back, only smart thing we had in our hand was a smartphone. Apart from computer, obviously the computer system from a huge large room has been reduced to the size of our palm with smartphones. But even till last 3-4 years, smartphone was the only smart thing which we had in our hand. But in past few years, there has been huge explosion with IoT devices. Although Google Home and Alexa has been around for some time, but nowadays even you have smart rings, smart watches, even your fridge, mixer grinder, washing machine, everything is. If you go to any sales shop, everything has an AI system embodied it. Everything is been sold as smart systems. When starting with almost all the components, and one of the requirement for smart system is the latency requirement. And obviously, since the smart system is located in a remote location, it cannot always interact with a centralized cloud location. So for example, every request, it will need to send the web request across to the server location, then get do the execution, then revert back the output to the device. That's really costly. So that's when the term or the concept of edge computing term came up, where the concept of localized execution inside those edge devices came up. So nowadays, the edge computing is a thing. Basically, when we are going with automated driving systems, in automation, ADAS features, in more high-level ADAS features in the automobiles, everything. These are our edge devices where the latency is really critical. You cannot have an ADAS system which is communicating with a server at some location and waiting for that output. It needs to have a edge system and a localized inside that device itself to provide that. So in generic term, so any of the Avengers fans, multiverse or sci-fi movies, if you are watching, you may have heard a lot about time-space continuum. So similarly, today's world is about cloud edge continuum. It's not about cloud or edge. It's about a cloud edge continuum where cloud is the brain and edge would be your reflex. So, so basically, when you put a hand in your fire, you don't ask brain that you should withdraw your hand. That's a reflex which happens. Similarly, edge in case of cloud edge continuum, cloud would be your brain and edge would be your reflex. So there would be a huge advantage in the and huge market rise in edge computing system. So cloud is the cloud system ready to adapt to those edge capabilities. That would be the second point which needs to be which determines how the cloud goes forward. And the third pillar, and as it's a cloud system, everyone is worried about security and everything. You may have also heard about lots of news about lots of celebrities, photos being leaked from iPhone, and lots of data leaks in the recent time. That's a concern even initially when we had when cloud was started. That was one of the major concerns. So with the cloud systems, security becomes a paramount of importance. And any cloud system which adapts to zero trust security feature, which means never trust anything or anyone, and identity first system. So always verify the identity before any transaction or communication. So that's the philosophy on the basis of which the zero trust security is implemented. So cloud which enables or implements this kind of system as a larger advantage. What's an identity first system? So basically, before any going into any interaction, you will be providing a token, and once that token is verified, only then interaction proceeds. It's like something in like if you've seen the movie Akere Akere Akere, it's like sadhanam kailundo, and the other person needs to validate it by saying sadhanam kailundu. Unless and until that validation happens, you don't proceed. So it's basically the identity first system also works in similar way. You have a token, that token needs to be verified at both the ends before it validating. You don't trust anybody. And the fourth pillar obviously is cost. With the cloud system, although the cost has been dramatically reduced, especially a common man like me and you can also now go and deploy an application in the cloud without much issues. But still, there is a, when you're creating a huge amount of architecture, the cloud, as you know that it's as the use of kind of costing model in most cases. So there needs to be a clear planning, and it led to creation of a new field called as FinOps. So basically, previously the financial team had nothing to do with IT, infra development, or actual computing world. But now we have a team which includes finance, architects, developers who would be coming together as FinOps, who would be designing and architecture the entire costing structure of this particular architecture you are going to implement in your cloud. So anyone who excels at implementing FinOps, because all these are pillars were optional till 1 year back, but going forward, these are not going to be optional. These are going to be a mandate if you want to succeed in cloud world. So cloud economics, if anyone wants to advance on it, then only they would be able to excel in cloud system. Although cloud is pay as you use, there will be many of us here who would have taken a gym membership or any subscription, but never used it. You'll just keep on paying that. So as you use kind of system has that kind of a problem. This happened with one of my friend. This is not now, I think around 4 to 5 years back. He had opened a trial account with one of the cloud systems. So basically, it had this much amount of credit was a trial as some kind of offer was running, and they had to. So if you are opening an account, you have to enter your credit card details. And he had entered the credit card details. You never use that account. He created an instance, but never on the first day, but never used it much and forgot about it. So about 1 month later, he got a bill of around $400 or something. It was not a huge one, but $400, maybe around 30,000 rupees or something. So he never used anything. He just forgot about it. So that kind of cost may incur if you have an architect, you have created a instance. Maybe there would be a big industry may have created a thousands of instances with a huge infra resource. And if you're not optimizing it at the best rate, that bill may be in crores. And those are all waste bills. So FinOps becomes really critical. So these are the major components or which would affect the future of the cloud computing. So as we have covered in this entire this, we try to unravel the mystery of the cloud computing. It's not a magic which is residing in somewhere. It's some intelligent engineers who has planned and developed an environment and architect behind it. so that we can create easily reliable, scalable, and interoperable environment for our applications. So this is a summary of what's cloud, basically what's cloud computing, why of cloud computing, and how. Most of these things, as I told, models, there are three basic models and three service models. Why cloud? Because cost optimization, reliability optimization, and it's more recovery is around 4 times faster than your on-premise environment. And which type of architecture are most majorly used? It's multi-cloud managed services kind of architecture, which mostly used. As I told, the AWS and market share is basically currently led by AWS, followed by Azure. And rest of them are, rest of and combined is owning the rest, basically IBM Cloud, Oracle Cloud. There are lots of other cloud entities which has specialized utilities. I just want to finish with this question. So basically, with the advance of cloud computing, the main question remains is that who draws this master plan, basically, since all of you are faculties, you would be the one who would be creating the future engineers. So this would be the question, basically, who would be driving you, basically, one of the engineers that you are creating or mentoring right now. They may be creating the blueprint for our digital future. So I'd like to wish you all well. Let me know if you have any questions. That's it from my side. Just another fun fact. If you there are lots of ladies over here. Over here, if you are investing in gold, currently the growth rate of silver in the coming years, means even now also, it's far more higher than gold, because most of the components used for servers uses silver. Basically, the chipset and everything uses a lot of silver. And the price of RAMs and GPU server is rising drastically because most AI workloads, they are just hoarding RAMs and CPU resources. So if you are investing in gold, it's better to invest in silver. That would give better return. Any questions? Multi-billion data center may soon become obsolete. I've not heard about that comment, but obviously, if you are referring to on-premise data centers, yeah, obviously, as we are moving on to cloud-based systems, there is a huge chance that such data centers will become obsolete in future. Since I've not heard that interviewer comment, I'm not sure on basis of what context you were saying that. Anything
Good
else?
evening, dear participants. If you have any more queries, kindly use the next 2 minutes to pose them to the resource person, because we will be starting this next session sharply at 8 p.m. Thank you. I hope there are no more questions.
Thank you, everyone.
So, Mr. Sudesh, thank you very much. On behalf of the Adi Shankara Institute of Engineering and Technology, I express a sincere appreciation for your valuable insights and for such an engaging and interactive session. Thank you very much, sir.
Thank you.
Dr. Victor, have you joined the session? Dr. Victor Paul?
And then let me check with him.
Yes, ma'am.
Yes. Hello. Am I audible?
Hello, sir. Good
Yes,
evening.
yes.
Yeah. Very good evening. Yeah, please.
So, good evening, dear participants. We now move on to the second technical session of day 1 of the 6-day ATAL sponsored online faculty development program on advancements in cloud and edge computing, research and industry perspectives. The second session focuses on an equally important and advanced topic, cloud virtualization, which forms the backbone of scalable, efficient, and resource optimized cloud infrastructures. It is my privilege to introduce our second resource person for the day, Dr. P. Victor Paul, Assistant Professor, Department of Computer Science and Engineering at IIIT Kottayam, with over 14 years of teaching and research experience. His expertise in cloud computing and virtualization technologies will provide valuable academic and practical insights to all participants. Sir, we are honored to have you with us. I kindly invite you to take over the session and share your expertise on cloud virtualization. Thank you, sir. Over to you.
Yes. Good evening, all of you. Am I audible? Ms. Parvati, can you
Yes, sir,
confirm?
you are
Yeah,
audible.
fine. Yeah,
Yes,
thank
sir.
you.
Yes, sir. You are audible.
Yeah, fine. Congratulations to all the participants, okay, for getting part of this very useful and maybe I can say like just in time. It is the uh, best thing to understand about the cloud and its environment, where it is expected to make like 80% of all the enterprises are planning to move cloud. It was expected to be in 2026 like 80% of all the enterprise level things will be moving onto the cloud. So I feel like it is the right time to learn more, or maybe I can say like a detailed about the cloud and its related concepts. Yeah, fine. Okay. So maybe I just share my screen, maybe the presentation.
Yes, sir, you can share.
Yes, yeah. I hope my screen is visible.
Yes, sir.
Yes, sir.
Yeah,
It is
yeah.
visible.
Thank you. So as I said, like the topic what we are going to have is like cloud virtualization. And before that, like I want to make something like clear, like as it is, the time is already 8 and till 9:30, it will be really hard for the people to concentrate on the technical talk, especially like what they not sure of. Maybe like I just as a technical or maybe a academician, I want to keep things simple. It is like rather than understanding maybe not completely all, I will make sure like you understand what actually virtualization and cloud and how virtualization helps to achieve cloud environment. So the plan will be in such a way like this is the plan. I'll be explaining though you people come across like what is a cloud computing as an introductory level. I just want to make sure from my end like what is a cloud analogically. I'm going to explain what it is and then how the cloud emerged actually. And then I will be talking about the few base technologies which actually paved way for cloud computing. Cloud computing is not a new technology. It's not an individual technology. It's a combination of or a collection of some 5 to 6 technologies that existed even maybe I can say like a 3, 4 decades before onwards. Okay. And I'll be talking about those. And one of the technology is virtualization. And I'll be talking about what it is and what is its purpose. And maybe I can say like how it helps you to achieve or helps cloud. And then I will be talking about different levels of virtualization as the topic suggests. So I'll be explaining you like what are the different level. If I take a computer system virtualization, what are the different levels you can virtualize it? And then I will be talking about relatively which kind of virtualization would be opt or maybe efficient. And then I will be talking about one of the main, maybe I can say like a component associated with virtualization. That is nothing but VMM, otherwise virtual machine manager, otherwise also called as a hypervisor. I will be talking about it. And then I will give some idea about what are the different maybe characteristics that need to be achieved by a VMM. And then I will be talking about different types of maybe virtualization depends on various criteria. And then finally, I will be giving you like maybe a small demo. It's not about like completely showcasing you what is virtualization, but I will be taking a tool called VirtualBox, and I will be showing you people like to create maybe a multiple system over a single hardware environment. Ultimately, that is what actually virtualization. Okay, so I will be trying to give you a demo on that. And most of the technical part of this presentation is retrieved from the textbook, what I showed there. So you can refer, or it is also suggested, basic cloud technology details or maybe the concepts. This particular textbook, whatever I showed there, will be an optimal one for it. Okay. Yeah. Moving on to the topic. So as I said, cloud computing is nothing but it's completely like transforming your computer hardware, software, and even including the networks as a utility. Maybe I can tell you like what is a utility means. Just think of like a electricity, whatever you have, maybe the water supply, whatever you have. Of course, not a gas. Maybe in US, even you can consider gas as well, where even the supply of the gas also being like an utility, like nothing but it will be provided to you throughout 24/7. How much you are going to use, you have to pay for it, nothing else. Okay, so your whole computer system, okay, hardware, software, networking, even application, everything is going to be converted as a utility. Okay, just like I said. And what is the primary purpose, or maybe I can say like the beauty of it is like it is something like comes under with something called dynamic provisioning. I can tell you maybe the thing is like I just planned for maybe my vacuum. It's not maybe I don't know like I didn't use it for a little bit, so it's not functioning as expected. So I will be using my mouse itself as much as possible to make a draw so I can explain you people. Okay. And the dynamic provision is nothing but like I can tell you like I will be showcasing some example and analogy to explain you what is dynamic provisioning. But you try to I will tell you like dynamic provisioning will also be one of the primary criteria I can say like a characteristics of cloud. I will explain this with an example later. Okay, and maybe so I will explain what is cloud with a small example. Assume like you are having a lab or you are having a computer collection of computer system, network computer system. Assume like it is 100 systems are there, and you own the lab, and the lab is having a collection of powerful or the recent CPUs and large memory and high storage capacity. Everything is there. Even you have a GPU systems and you have a very fast IO devices like network card. Everything is there in your lab. But what is the thing is like the lab is getting utilized maybe from 9 to 4 p.m. Okay, like around 8 hours of 9 hours of that more efficiently. And outside of those hours, the whole lab is going to be completely free. I mean, it's like the hardware, whatever you have, is getting not utilized. Okay, it's completely idle and switch it off. It's not going to be used. Okay, now assume like there is a person or there is a group, there is a research group, either in your institute or from the outside. Okay, they are approaching you, telling that maybe you just give us your system, not the system physically, just provide us a network connection or to access your system virtually or through network. Okay, and assume like the research group is having a high computing requirement, but they don't want to buy a supercomputer. Rather than buying a supercomputer, they want to distribute the work. Okay, the high complex work among the 100 systems distributed way, so that they will get the output from each system individually and they will consolidate it to satisfy their task or to achieve their task. And they are approaching you as a lab owner. Just give us your system, access remotely from maybe like after your utilization from 6 to next morning 6 12 hours, and we will be utilizing your computing resources including your RAM, your processor, your storage, everything. And of course we will not be touching any of your private data whatever you stored there. Under this, if they are asking you, and also like they will be paying you for every hour they are using the number of system of 100, and of course you will be saying yes, right? Because like rather than keeping it idle for 12 hours, just keeping it switched on, somebody will be using it remotely. Okay, and they will be paying you as much they use. You will be saying happily yes, right? Of course, that is what a cloud computing. Now I can tell you one more thing. Who actually made this? Like maybe I can tell you like I will take an example of AWS, where Amazon. Maybe like I can tell you like uh, can you people tell me like why Amazon established large scale data centers? Even before cloud services, they have a large scale data centers. Actually, they created data centers primarily to satisfy the customers, like their Amazon portal and other their retail shop, everything. Like they have a huge computing requirement because they have thousands and thousands of branches, and they have millions of users to use their online shopping as well. To satisfy their customers, actually they created large scale data center. Maybe I can tell you one thing. If you look closely, the number of purchases, online purchases, okay, will be more during the time called maybe the prime time, the big day, something is there, right? So I can tell you, people will be purchasing millions of product. I'm just showing an example, millions of product transaction every minute. Okay, but if you look not other days, it will be like around 10,000 transaction per minute. Comparatively, it will be like 1,000 times lesser than the normal, I mean, the peak days. Okay. But what happens, the Amazon, all those big companies, they establish the data centers or the computing that are required for their peak load. They will be making it for their peak load. Okay. And if you look closely, apart from those peak load days, all other days, those resources will be free, just same as the lab, whatever I said. So what they thought, rather than keeping it idle, why don't we make money out of it? We will give that resources to somebody to execute their maybe their computing offloading to our data centers, and we will get paid. That is the starting point of making a business out of the environment. But I won't tell like cloud computing is created over a night by AWS. It is not so. It was like in the discussion from maybe 2 decades onwards. Okay, so this is a clear analogy, or maybe I can select how it can be mapped. Okay, yeah, this is what actually I was trying to say. Like your lab and your physical system, whatever, maybe like a physical lab, whatever I said, it's nothing but data center, idle system, underutilized resources. Okay, because they established large scale data center, but it is underutilized in non-peak hours. Okay, so external users where you're I'm allowing to my lab, they are nothing but the cloud customers. Okay, and whatever I said, secure access, that is like whatever the data I'm going to store, it is completely isolated. No users will be accessing others. Okay, and of course, paper use. These are all the important characteristics of cloud, and this is same as lending your lab virtually to a third party. Okay, and yes, of course, the diagrammatical way of explaining the lab and it is same as the large scale data centers, which you will be utilizing it from your place and you will be paying them whatever you use. Okay. And now maybe more detailed about your cloud. Maybe usually like previously it was like a large one single system which is of the size of a room. If you take 90s, early 80s, a single computer of a completely a size of a room. Then it was made as a one desktop, and then it is made as one laptop. Now you can access computer without a computer. I can say like if you want to access a maybe a high performance environment, maybe a system with 10 GB, maybe I can say like a system with maybe i9 processor with the 30 or 64 GB RAM and with maybe storage of very high. If you want to have the system, you can access the system without that actual system. Okay, that means maybe a preliminary system or maybe a basic system with just a browser connected to a high-end maybe internet. You can access the computer, whatever I said of the configuration, without having that by using the cloud. That is what the computer is lost. That is nothing but your cloud technology. Okay. Yeah, that is what I said. Any user with a simple browser and a high-end, maybe a highly speed internet, okay, they can access any kind of HPC, high performance computing environment using cloud technology. Okay. And this is what the just the pictorial representation. Usually before it is everything is on premises. Whenever a company want to have maybe a computing environment, they have to create buy their own server, and they have to buy their own storage and their own networking, and they have to have their own IT support people to maintain everything that is on premises. Now what is going to be there? So they don't need anything. Okay, just subscribe with your credit card. Okay, and all this whatever you established on premises will be provided by the cloud provider. Okay, just subscribe it and access it everything. Okay, and this is the maybe at the end of this maybe your uh, talk, or maybe after this FDP, maybe you people need to know like at least like a standard definition. This is as per the NIST. Okay, as academician, you people must know like a standard way of defining it, the cloud, because you can find hundreds and hundreds of definition for a cloud, but the standard one which will be given by the NIST. Okay, and as per that, it is a model. Okay, it's a technology that enables a person or a user access ubiquitously from anywhere, anytime, convenient, easily. Only thing is you need a browser, and other thing is like you need a internet, and on demand. That means whenever you require. These are the three characteristics. And on demand, access to a network. So you will be given access to a network. The network access can be, you can get it from anywhere, anytime, in an easy way, just by connecting to the internet, and whenever you require, you can get that network access. And this network access is nothing but you will be getting the access to a shared pool of configurable computing resources. That is what it means, like a shared pool. The shared pool here refers to, any idea what it refers? The shared pool is nothing but the data center, whatever we discuss. So whenever you talk about data center, it is nothing but a huge collection of computing resources. Maybe consider like a huge building completely with a collection of network, okay, collection of processor, collection of racked RAMs, collection of storage SANs. Okay, it's a complete whole building itself completely of this. But every resources is a configurable. That means maybe sitting in one place, maybe assume like you are a data center coordinator or the in charge, sitting at one place, you can access any part of the huge pool of memory or the resources, whatever you have. I am just telling you, like, take a room full of racked RAMs. See, even your single system is having 64 GB RAM. Assume that whole room is having racked RAMs. It will be in terms of like hundreds and hundreds of terabytes of RAM within a room. But no matter of what, it's all connected, it's all configurable. You can access individual objects of RAM from a single place. That is what it means. It's all share. It's a pool of resources. It's all share, and it can be configurable from anywhere. Now, what happens is you will be provided network access to this shared pool whenever you require in an easy way. Okay. And increasing and decreasing of these resources will be provisioned or maybe like provided to you in a easy way. Like I can say, like there won't be, you need not to tell any person, provide me 64 GB RAM now. You need not to. Just you go to login and increase it, decrease it on your own. It will be provided to you without any kind of human effort. That is what it means, like provision rapidly and released. You don't want the system or whatever the creator you want to release it, the resources, you can do it. Assume like you want to create a system at the moment, maybe like with as I said, like i9 processor and 64 GB RAM and 10 terabytes of storage. So if you subscribe it, next minute you will be getting that system. They will be providing you a URL. Just type the URL on your browser. Okay, you will be getting access to that object. So you will have now system which is having the processor, RAM, whatever you ask, and you can use it. You can develop application. You can create whatever you want. And at a moment, so the requirement is completed. So you can write to that particular provider, I don't want the system. So they will release it. So no more object will be there, and you have to pay them whatever you use. Okay. So that is actually a cloud environment or a cloud model or a cloud technology. Okay. So again, it's a diagrammatic way. And I guess the introductory level, they might have told you there are different maybe scenarios are there, like why it is named cloud. And the most common one, the standard one is like the representation. So internet is the reason. Cloud computing is also called as internet computing, where without internet, you can't go for it. So since maybe if you take network diagrams, your internet will be provided in this fashion, maybe like this. So which seems like a cloud. So that is what the standard term, like that, why it is named as cloud computing. Okay. So referring to the internet. Okay. Yeah. And as I said, yeah, I said previously, like your cloud computing provides dynamic provisioning. Think of a, maybe I can tell you, take a bank, or maybe I can tell you like a, take a bank where they are having their own on-premises infrastructure. Maybe the bank, maybe this is the time, maybe over a year, and this is the requirement. Okay, number of users require a number of transactions per second, whatever it is. Assume like a bank. Okay, now, so the bank initially set up one infrastructure. This is the infrastructure they set up, and their customers are increasing slowly, and they are utilizing it. And suddenly, I can tell you, like maybe I can tell you one example. The number of bank transaction that happens, okay, maybe first 5 days of a month, okay, will be relatively large when comparing to the number of bank transactions that happens from maybe between 10 and the 20 or maybe the 30. It is maybe the common thing. The number of transaction between first 10 days or 5 days will be highly more, okay, or more when compared to 10, after 10 to 30. Okay, so assuming that maybe the number of people using it will be higher, and after that it will be reducing. So the bank observed that, okay, there are a lot of people trying to use, but my infrastructure is not so. So they are trying to increasing their demand. So infrastructure is increased. So still over it, their number of customers are increasing again. Okay. And you can see here their infrastructure can satisfy only these many number of demands, but the demand is getting increased. These are the thing you can call it as a under provision. Even though the customers are trying to do transaction, their infrastructure is larger and not larger enough to satisfy it. The bank people observe it. Again, they are increasing their infrastructure more over a period of time. But even you observe it, after that initial thing, again, it will increase or decrease. So again, their infrastructure will be underutilized. Even though it is more, it is not utilized. Again, first few days, it will be more in the next month. So again, they will be, because bank or any business, they will always plan for their peak load, not for their load. So even for the peak load, they will increase their infrastructure. But after that peak, again, it will be underutilized. So either it will be over provision or underutilized. So here you can say like underutilized. Okay, so that is the reason, that is the drawback that is with the on-premises infrastructure. So if you look at the cloud, so if a bank is subscribing to the cloud, so the infrastructure provided to you will be increased automatically when the number of customers increases. That is what it means, dynamic provisioning. That is the main criteria or characteristic. So when the number of demand increases, the infrastructure provided to your business will also be increased. If I'm subscribing to maybe a cloud or a Google or somebody, I need a high-end server to provide service to 1 million user. Yeah, that is enough. But when the number of customer increases to 2 billion, automatically your cloud will increases the provisioning resources to twice the amount of whatever they provided. So, and whenever the number of customer reduces, automatically your cloud will reduce the service provider or maybe the infrastructure provided to you so that you will be billed less. So that is what, when the number of demand increases, your infrastructure also will be provided more. And whenever the demand is reducing, number of user is reducing, the infrastructure provided to you will also be reduced. So you have to pay only for whatever getting utilized, not for over provision. So that is the main criteria or maybe the characteristic I said as per the dynamic provisioning. Otherwise, you can also call as a pay-per-use. And cloud computing will be usually used by the larger enterprises and smaller as well as the end user like us. So larger enterprises usually used to offload their partial computing, and smaller enterprises like startups, they will be subscribing for the cloud, okay, rather to avoid initial capital spendings. Okay. Yeah, I think you might have discussed this in your previous session as well. AWS is the most prominent provider, followed by other two, or maybe these are the three prominent, and all others will be also increasing over a period of time. Yeah, here I come. Initially, so while people are talking about like this, like a standalone computer was initially there, and they found they want to improve the maybe the computing efficiency. They moved on to the next level of technology that is called client server computing, where the high-end system will be only one, and maybe the dumb system will be a collection of clients, and they will be offloading the computing to the server. So the client server technology was there to overcome the drawback in the standalone. And still they made more technology, that is mainframe. They made the server more efficient or more high-end one, but still there's a lot of spending need to be done to maintain and purchase the mainframe. There is another technology that brought up that is called peer-to-peer. Rather than having one high-end mainframe, we can have a collection of lower level computers, and that gave birth to something called a cluster computing. Okay, and then this cluster computing again more maybe I can say like a efficiently made. It's a distributed computing environment, otherwise distributed system. Otherwise, example is nothing but your internet, where each and every system is individually having all the resources, and they are computingly and they are connected to one particular network, and they can join and they can release on their need. So this is the base technology. Along with, there are some more technologies. Maybe you can control this: utility computing, Web 2.0, virtualization, and you can also call as SOA. That is also one technology, service orientation. So these are the five, 1, 2, 3, 4, and 5 different technologies actually put together. They gave birth to cloud. Now we are going to talk about only one technology out of this, that is virtualization. What is virtualization? How it makes cloud possible? Okay. Now I'm going to talk about virtualization. Virtualization is nothing but it's a simple means like simple to understand, but not as simple to achieve actually. It's a technology where you will be making a ability to run a multiple operating system or multiple users to a single physical system. Maybe I can tell you like this. You have a very high-end computer, or you have one computer, hardware. Hardware is there. Okay. But what you want to is like, since it is very high-end computer, if a single person is utilizing it, okay, then he can't utilize it to the most. Assume like this is having 24 cores of processor, and it is having like a, as I said, like a 64 GB RAM. Okay, and then it is having like a 10 TB of terabytes of storage. That's what I said, like it's a HPC system. Okay, if you are assigning this computer to one person, maybe he can utilize it to the most, maybe a few times a day, like whenever he is executing a complex task. The whole all these resources will be utilized completely. But apart from that particular period of time, this hardware, whatever I said, will be underutilized. So assume like this system is having GPU of 10 GB, GPU of 10 GB is there, and it is having very high-end network card, all those things is there, but still it will be underutilized. But what you can do, the requirement of the company is going to be something like how I can make the same environment or the same hardware can be utilized or can be used by multiple person. Okay, there comes the need for virtualizing. So this single hardware can be virtualized so that multiple person can access the same hardware at the same time. That is going to be something like this. So this is user one. He can have his own operating system. Okay, and this is user two. He can have his own operating system. And this is user three. Maybe they can have his own operating system. Like that, you can have multiple users. So all these users will be utilizing the same hardware without interfering the other. That term we will be calling it as an isolator. Each user will be completely isolated from the other, but they will can execute all their thing on the same, maybe the hardware. So how it can be done? By the concept called virtualization. So in order to do that, okay, so they need to have a special thing, a special, maybe I can say like a component that will be called as a going to be like an intermediate, that is going to be somewhere here between your virtual machines and the hardware. That is nothing but virtualization layer. So you have to make a virtualization layer between your virtual machines, whatever you want to create, and the hardware which you want to virtualize. Once you created the virtualization layer, then you can create n number of users or n number of operating system over a same hardware. That is what it means. So virtualization enables or provides ability to run multiple operating system on a single physical system to share the underlying hardware resources. Okay, the primary purpose of virtualization usually like to utilize the resources more efficiently. That's the primary thing, and also to achieve portability that we will discuss more detail later. Okay, and this is what actually people are doing even now. Maybe in your institute or maybe the college, your college will be buying very high computing environment, like usually HPC system. Okay, and this HPC system, like I can tell you, like rather than providing GPU, like I can tell you, like a research perspective, each and every faculty wanted to do maybe deep learning models execution, all those things. That rather than buying maybe individual system or individual ability, I mean individual computer to each and every faculty, they will be providing you, like they will be buying very high-end computing environment. They will be setting it up just like this, very high-end computing environment in one server place. And whenever a faculty requests for maybe a computer, and they will be creating one virtual machine like whatever I said, and they will be providing the access to you. And all these people, remember guys, all these three or all this n number of virtual machine can access this hardware parallelly at the same time. Okay, at the same time they can utilize it. Okay, and you are hypervised that the virtualization layer, whatever I said, that will take care of how efficiently to utilize the underlying hardware. Okay, so that is what means of a virtualization. Okay, so maybe the diagrammatic representation, it's a traditional system where hardware will be there, over that kernel or maybe the operating system will be there, and over that you can have maybe the process application whatever you run. So application will communicate to the OS will communicate to the hardware, and the communication will be revert back. But when we compare to virtualization, as I said, hardware will be there, and you will be creating one layer here. This is the layer I said, that is nothing but virtualization layer. And once it is created, that visualization layer or the technology that enables you to create multiple individual computer that are not real computer, that are virtual computer, that will be called as a virtual machines. So you can have multiple over there. So each machine is an individual computer like. So you can have your own OS and you can have your own collection of application over that. So now each and everything is going to be like an individual computer like, you will call it a virtual machine. And all this virtual machine collectively can utilize the hardware so that the high-end system will be utilized more efficiently. Okay. So I just tried to explain, wanted to explain with the analogy, but yeah, with respect to time constraints, I will be skipping it. Like I just explained this. One high-end physical server, okay, and each machine you are going to create virtual machine. Okay, so actually I wanted to explain like maybe like assume like there is this one big home or a big house is there, not a home, house is there, and the house is having a collection of rooms, hundreds, I mean tens of room is there, and tens of maybe I can say like restroom, kitchens, all those are individually is there. If a single family is using it, yes, of course they can use it, but they can't utilize all the resources efficiently. So what you are going to do, you are going to have a building manager, a person who he will be doing like he will be altering the house in such a way like each room and maybe the restroom, kitchen together one cabinet. Okay, and similarly they are arranging one that house into a maybe collection of 10 different apartments. Each apartment will be having its own room and maybe the kitchen, everything. They are just cabinet it, whatever they had already. Now, in I mean, the electricity, all those things will be provided. Now, this each cabinet or maybe the room or maybe I can say like apartment can be given to single family. Now, 10 family can utilize all the resources, okay, which are common or which may be underutilized by a single family. Now, there is going to be some person, okay, who will be monitoring which room utilizing how much electricity, how much maybe I can say like a water, and they will be monitoring individually. And he will be taking care of how much maybe the pay they have to make. There is a person, maybe I can say like a building manager. He will be assigning if a family is coming, like I want a room with this size, with this facility, and he will be checking out among the 10 rooms, whatever he have, and he will be assigning the room to the particular family, and they will be using it. And he's the person who will be monitoring all the thing within this apartment. Okay, there is a reason for explaining this. Okay, he will be checking out each family, how much electricity, how much power, and how much maybe the number of rooms, number of kitchen, all those utilities, everything he will be monitoring about each family. And he will be giving bill to each family, how much they have to pay based on their utilization. The same thing is applicable here. Okay, one physical big server that is same as a big house, and you are dividing one big house into collection of apartments. Okay, and here you will be having collection of virtual machines, and each family is using the apartment. Here the users using individual virtual machine, and maybe I can say like a monitoring. Okay, so monitoring is that how much resources they are utilizing. Same way, the virtual machine, how much resources, like maybe sometime it will use 16 GB RAM, sometimes it use 32 GB RAM. Remember the maybe I said like a dynamic provisioning. So depends on the virtual machine demand, the dynamic provisioning. So it will differ from time to time. So there should be somebody to monitor how much resource is being provisioned or provided to that particular user. So that will be done by same as the building manager. Here I said there is something called a hypervisor. So hypervisor is going to be somebody. Otherwise, I can say like hypervisor is nothing but this person. So the virtualization layer, that is nothing but the hypervisor who is going to be a monitor. So that also will be called as a VMM. That is what I'm going to talk in the very next slide. The hypervisor will also be called as a VMM, virtual machine manager. So he's the guy or he's the layer, it is the layer that manages all the virtual machines. So he monitors how much resources each virtualization or a virtual machines are getting used. So sometime maybe this virtual machine maybe like use 16 GB RAM. So whenever it is not utilized, so it will be using only 1 GB RAM. Okay, and this maybe kernel or maybe this virtual machine might be using like 64 GB RAM while there it is executing some deep learning model. And once the execution is complete, so it will be using only 2 GB of RAM. So whenever the deep learning model is getting executed, it will be using 2 terabytes of storage. Okay, and otherwise it will be using only maybe GBs of storage. And the same during execution, it will use maybe GPUs. Otherwise, it won't. So the particular VMM or the hypervisor which lies here, it completely monitors which virtual machine utilize this hardware and how much time. So all the records will be here with this particular component. These components give the bill to this particular VM depends on the billing structure. So you use this particular hardware infrastructure for this particular period of time. So you have to pay this. So all these things will be done by this particular layer. That is nothing but a VMM. So now a virtualization is nothing but maybe in order to improve the maybe efficient utilization of the underlying hardware, okay, rather than a single user, you're going to provide a single hardware to a multiple user. Okay, so you're going to have something called virtualization over your hardware. And if once it is virtualized, the hardware is virtualized, you can have multiple virtual machine over that. And there is a person in between that is called a hypervisor. He will monitor all the activities of virtual machines, how much they utilize the hardware. Okay, accordingly, he will provide bill or generate bill, whatever it is. Okay. Now we are going to talk more about like visualization. Okay. So as I said, there are two ways. Generally, we will be talking about this later as well. Okay. Maybe usually visualization will be of two types. Okay. One will be something called a native or bare metal, and second one will be called as a hosted usually. Okay. So I will tell you like when it will be preferred or when it will be like which type of virtualization will be preferred. And this is your typical physical system where over your hardware you will be installing your application or sorry your OS, and over that you will be installing applications like your MS Office, Java, all those blah 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 things, and you will be utilizing it as a single system. Now, there are two virtualization techniques I use. One is like a native or bare metal, and second one it will be called as a hoster. The structure will be in such a way like you will be having a high-end hardware. Over that, you will be having hypervisor. Just try to understand. Over the hardware, you will be having directly the hypervisor. Okay, over the hypervisor, you can have n number of virtual machines, not necessarily one. You can have n number of virtual machine. Each virtual machine can have its own operating system. Usually we'll be calling it as a guest operating system. Okay. Now the second technique, something is going to be something called hosted virtualization, where it will be like you will be having the hardware. You will be having the hardware. Over that, you will be having host OS. So I said like I will be giving a demo. So I will be giving a demo about this. Okay, so you will be having some operating system over the hardware. Okay, and over that hardware, you will be having a software that will act as a hypervisor or virtual machine manager. So you will be installing one software over your OS, and that particular software will act as a hypervisor. And over that hypervisor, you can have n number of virtual machines. So according to the structure, if you look closely, hardware will be there. Over that, if you directly install the virtual machine manager, otherwise hypervisor, that will be called as a bare metal because you are installing the hypervisor over the directly on the metal. That is nothing but the hardware. So such a technique will be called as a bare metal technique or bare metal hypervisor. And this way of technique will be called as a hoster. See the structure the same. Okay, hardware, host OS, and over that you have virtual machine and then number of guests. Okay, such a technique will be called as a hosted or otherwise type 2 virtual machine manager. And if you are going to install the hypervisor directly on the hardware, that will comes under type 1 or native or bare metal. All names resemble or refers to the same technique. Okay, now when we can prefer hosted and when we can prefer native. See, that thing will be simple. Like whenever you want to have a visualization environment where very few less number of users or less number of virtual machine you are going to, maybe I can tell you like I have a Windows environment, but I want to run Linux, or I want to create a Linux environment over my Windows environment or a thing. Then you can prefer hosted. Maybe it is more easy to establish, okay, and maybe relatively not efficient, okay, but resource concern, like if you want to have only less number of guest OS or guest virtual machines, you can prefer this. Whenever you want easy to establish and not so many number of virtual machines, you can prefer hosted. But industry scale level, you want to have a very efficient way of virtualization, then you can go for this. Maybe I can say like bare metal, where your hypervisor will be very efficient. Your hypervisor will take overall control, and that will take all the monitoring or maybe the recording of all the virtual machine, providing the resource. See, if you look closely in this native method, there is no OS, there is no guest, or maybe I can say like a host OS. Your VMM itself will act as a operating system, providing the resources, retrieving it, and freeing it. Everything will be done by your VMM itself. Okay, so remember, whenever you want industry scale virtualization, you want to create hundreds and thousands of virtual machine over the common hardware, and you want to utilize those hardwares more efficiently. Okay, and you don't want to maintain it. There should be some hardware that, sorry, there should be some software that want to maintain it to the peak without a very less human intervention. Then you can prefer native method of virtualization. All your maybe high-end or maybe cloud providers, as well as I said, like your institute-wise, having HPC and providing the access to all the PhD scholars and faculties, they will be preferring native VM technique. But as a individual user, I want to create my Linux virtual machine on my Windows, or I want to have a Windows environment on my Linux. I want to create a Mac environment on my Linux. You want to make it, then you can plan for hosted environment, which is relatively easy to achieve. Okay. Now, apart from this, here, whatever I explained you, that's all simple kind of server virtualization, whatever I explained simply now. You can virtualize desktop, you can virtualize a storage, and you can virtualize network, all those things. Maybe I can tell you one thing, like maybe whatever you people are, or we people are using, Google Drive, Dropbox, it's all comes under storage virtualization. They will be having millions of TBs of storage, okay, and they will be having a virtualization layer over it, and they will be giving access to all of us, like maybe millions of Google users are using the Google Drive, the same storage. See, your Google Gmail will say like you have 2 GB of storage, but that doesn't mean they will be allocating 2 GB RAM or 2 GB storage to it. It doesn't mean so. Okay, so all of us are utilizing the common storage infrastructure, whatever the data center they establish. This virtualization layer that provides the storage whenever we want. Okay, so it is not like allocation individually, it is like on demand. Whenever you want, the storage will be allotted. Whenever you don't want, the same storage might be used by somebody else. Okay. Yeah, that is what the beauty of virtualization. Yeah. And coming back to the technology, so maybe as I said, like it enables the user to share expensive hardware resources by multiplexing the VM. That is what it means, creating multiple VMs on a same hardware. Okay, so allowing a single machine, that's a high-end system, as if it behaves like a multiple smaller virtual machines. So it is completely implementable by using the concept of hypervisor. Okay, it's nothing but a software. So these are the example, guys. So look at here. These are all nothing but example for, I mean, real-time tools or example for hypervisor. These are the example for type 1 or type 2 hypervisors, where it will be coming under hosted hypervisors. And these are the example for native or maybe the bare metal hypervisor. Okay, we have used VMware SXI, where we bought a very high-end system. We installed VMware SXI, and that give you complete control. You can create n number of virtual machine and you can provide to anybody, whoever you want. Okay. Yeah, this is maybe again diagrammatical representation, traditional hardware and operating system and application. Once it is virtualized, so once you have a virtualization layer, so you can have individual system like this, individual system. Okay, and each system can have its own guest OS, application, everything. And look at here, guys. Here you have a hardware, but this is not a physical hardware. You will call it as a virtualized hardware or virtualized resources. Assume like my server is having, I said like maybe 24, maybe I just want to write like a 24 cores. And I said like a storage, I mean, memory of 64 GB and the storage of 10 TB. I said already, right? Now I can create a virtual machine. I can create a virtual machine, okay, with maybe 4 cores, and I can create with 12 GB RAM, and I can have like a 2 TB storage. This virtual machine can be created with this configuration, okay, and I can create another virtual machine where I can allocate like a 10 cores, and I can have like a maybe 24 GB RAM. I assume like high-end computing environment I want to create for this virtual machine, and maybe I can make like a 5 terabytes of storage for this virtual machine. But keep in mind, guys, it is not like all these resources, all the configuration will be allocated directly to this machine. It is not so. Okay, so this allocation will be done whenever it is required. The machine, the hardware, whatever it is there, it is common to both this virtual machine. Okay, even I can create one more virtual machine. Remember, guys, even I can create one more. So it is 24 core and 10 core. Even I can create another virtual machine of 10 core. Remember, another virtual machine of 10 core. Okay, but if you look close, not 10 core, I can create for 12 core. I just tell you like I can create it for 12 core. Okay, but if you look closely, 4 core is there and 10 core is there and 12 core is there. Totally, it will become 26. But my actual core is 24 alone. Okay, but what happens is all these VMs will not be at a peak utilization all the time. Maybe sometime it will be using 1 core and sometime it will be using 10 core and sometime it will be using 5 core. Are you getting, guys? Could you able to understand? So the virtualization happens to be maybe it's like a on demand. Whenever the hardware is required, it will be provided by the virtualization layer or with hypervisor. Apart from that, still it will be like a common pool. It's a shared pool of resources. The pool will be allocated whenever required, and whenever it is not used, it will be freed and it will be assigned to some other virtual machine. That is how it makes the high-end environment or the resources utilized more efficiently rather than a single user. Okay. So that is what it's about, virtualization. And maybe I can talk about, yeah, the technology is what I share. Yeah, virtualization can be done at the different levels. As I said, usually as per maybe following the technology or maybe the academic perspective, even not necessarily the industry perspective, academic perspective, usually there will be like a 5 levels of virtualization. One will be the basic level will be called instruction set. Okay. And then second one will be hardware level, operating system level, library level, and application level. I will give you one overview. Okay. See, usually visualization, I already told you people, virtualization is primarily for 2 purposes. One is to utilize the hardware, underlying hardware more efficiently by having multiple users. That is one. Second one is to achieve portability. Okay. To achieve portability on the same hardware. You will be having some hardware. By using virtualization technology, you can achieve portability, or I can say like a interoperability. Now I can say one example, guys. Not maybe I just with a friend. Maybe I can give a small example in this. Maybe if you have handled computer organization, or maybe if you are well versed with processor architecture, there is something called ISA. instruction set architecture. There'll be you might have come across something called a CISC architecture, RISC architecture. Okay, so usually your processor will be having that particular architecture. Example, I can say in the next slide, I think you can have something like this. Yeah, see, there is whenever we talk about ISA, there is usually called x86 architecture, which comes under CISC, and there is something called a MIPS. One of the type of computer architecture where the instructions will be different for each. Okay, maybe I can tell you like your Intel based instruction sets are based on this x86. Okay, and your MIPS based will be or following CISC way of instruction set. Now what happens is, when assume like I have a Intel architecture, I have an Intel processor which have maybe maybe a RISC, or maybe I can select x86 instruction set. But I have a code, I have a program. This particular program actually created for not x86, it is actually being created for MIPS. Are you getting guys? For MIPS instruction set. But I want to execute it on my current maybe x86 environment or x86 processor. But generally it is not possible, because the instruction set of MIPS, the program, whatever you have, it is completely different when compared to x86. You can't execute it. But what I can do, I can create a virtualization layer in between this, okay, using the level called instruction set, where this particular virtualization layer, what does, it will it will take the instruction set of maybe like your MIPS and convert that particular instruction set into its corresponding x86 format, and it execute here, and it retrieves the result and converts it in such a way like this instruction set can understand. Could you able to understand? Now I'm completely virtualizing my underlying processor architecture or maybe the instruction set. Even though I have x86, I can execute a program, okay, that supports only MIPS instruction set by using the concept of virtualization. By using ISA virtualization or maybe the instruction set level virtualization, I can execute any program or maybe the program that are created for any type of instruction set, not necessarily my computer's native instruction set, by using the concept of ISA virtualization or ISA level of virtualization. The next thing is going to be like hardware. Okay, maybe what I can tell you, like whatever I explained now so far, you have a huge pool of hardware, and using the virtualization layer, you are going to use the common hardware among different users. That is what hardware level of virtualization. Hardware will be there, a single huge hardware will be there. By using this virtualization layer, which is comes under the level of hardware level virtualization, you can have n number of users to utilize the common hardware. That comes under hardware level virtualization. I think I have some diagrammatic representation I will go for next. Operating system based is nothing but I can tell you like this. Maybe I have one hardware, okay, and maybe I have maybe one level of operating system. Maybe I can talk about something like kernel. Maybe I can take like a Linux kernel. Maybe a Linux kernel I can have here in this layer. Okay. And what I am doing, so I can have a virtual machine. I can have a n number of virtual machine which have any flavors of operating system that have a basic of Linux. Maybe I can say like a Fedora. Maybe I can select a Debian. Maybe I can select a CentOS. All these OS are basically Linux based. Are you getting? Now what I'm going to do, I'm going to create one layer. I'm going to create one layer in between. Okay, this layer is going to have a kernel that is necessary for Linux. The kernel, it won't have all the library and all the device driver, everything. It will have only the kernel part. Now I'm going to have a virtual machine. This virtual machine can have a complete OS, the OS any flavor of Linux. And here this particular person can have Debian, and this particular person can have a CentOS, and this can have a Fedora, and it can be any operating system. But if you look closely, okay, so the person are going to use the underlying common operating system, that is nothing but your Linux. So why it is like more thing, it will be more efficient, because I can tell you like only the part that are required, that only the device driver and all other application drivers also only will be there in the virtual machine. All other complete control will be taken care by this OS, the common OS that exists. Okay, so this is the way of virtualizing OS. That means the underlying hardware or underlying OS is going to be single kernel. Over that, you can have any different level or any different operating system that supports this particular kernel. But one thing is like over the kernel of Linux, you can't create a virtual machine with maybe Windows OS. That is not possible. Okay, you can't achieve OS level of virtualization of uncompatible or incompatible kernel. Okay, so that you have to make sure. Okay, so such a way of maybe achieving virtualization at the OS level. If you have here different OS and here you have different OS, but all these OS are being executed on the same hardware without any kind of interference. Such a level of virtualization will be coming at the operating system level of virtualization. And the last one, or maybe I can tell you the requirement. Maybe I don't know, like how many of you executed, like have you ever executed Android application on Windows? Is there any tools you come across? You can execute Android application on Windows environment, or you can execute Linux application on Windows, or Windows application on Linux. I think, have you come across that? Is there any tools you use for that? Maybe I can check out chat or anything. Any tool you have used? Maybe I can give some example. Maybe Sigwin, Wine, the tool Sigwin, the Wine tool. Maybe I don't know, like, how many of you come across something called a BlueStack? There is a tool called a BlueStack. Yeah, yeah, thank you. These are some of the tools. Okay, maybe you can do execute. Maybe BlueStack is a tool using which, if you install BlueStack onto your Windows environment, you can execute Android application on Windows itself. It will work. Okay, and similarly, if you install Wine, okay, you can execute maybe Windows commands on Linux. And if you install Sigwin, you can execute Linux commands on Windows. Okay, so what actually you're doing here? So you're not virtualizing the whole computer. You're not, why, what I'm saying is like, you're not creating a virtual machine here, but you are creating a layer. Okay, that BlueStack. Okay, maybe I can tell you, like, whenever you are installing BlueStack, I don't know. Yeah, whenever you are installing BlueStack, maybe your hardware is there and your Windows environment is there. Okay, and when you install BlueStack, that will create a layer over your Windows environment. This particular layer enable you to execute Android application on your Windows OS. Nothing but whenever you executing Android application like a game, okay, so that game details, or maybe the game will communicate to your BlueStack. BlueStack is nothing but maybe I can say, like, it's an example for library level. Okay, like what it does, it will convert the Android application code in such a way like it can be understandable to the Windows operating system. This virtualization will be done in between by the two. Okay, and your Windows will execute the code as like its typical native code on this hardware, and whatever the output will be returned back, and the result will be given back to that particular Android application. Of course, it's a time consuming because of the translation, but it is virtualizable. Such a way of virtualizing, rather than creating a complete virtual machine, you are virtualizing only the library. Whenever the API is need to be called, so only by the time your virtualization will be called, rather than creating virtual machine individually for each and every user. So you will be creating a layer that will be enabled only for API translations. Such a kind of virtualization will be coming under library support level rather than complete virtual machine. And last one will be coming under like a, maybe I can say like a completely virtualizing. Maybe as a faculties, maybe you might have come across maybe your Java virtual machine, JVM. Okay, JVM, you people does know like Java achieves portability. Java is completely interoperable, no matter what is the underlying hardware, what is the no matter the underlying operating system. You can execute Java program that is created in one environment on any other environment without any kind of issue or maybe the problem. That will be done by using the concept called JVM, which is nothing but one of the concepts that comes under virtualization. So what it does within your operating system, it creates one specific kind of virtual machine that is not a complete virtual machine, but it is like a I can say like it's a subset of virtual machine. And this virtual machine executes the program whatever you want to execute. Remember, maybe the listeners, say example, Java program. Java program will never be executed by the host operating system. Java programs will be executed within the Java virtual machine that executes. That is how your Java achieves portability. Okay, that can be an example for application level of virtualizing. So these are the 5 levels usually. Okay, like as per the requirement, you can virtualize or you can make it all the thing. Okay, now here is a stack, as I said. Example with like your JVM, maybe as I said, like your wine and your CUDA, and maybe I can call up like your Sigbean, everything will come under library. And operating system level, as I said, maybe your LXC. I think if you are used in Linux environment, LXC and your container technology, everything will be coming under operating system level. And the hardware, all the tools, whatever the hypervisor I showed before, everything will be coming under hardware level of virtualization. And maybe QMO is one of the famous tool which usually will be used to convert maybe like x86 instruction set to executable on MIPS. Okay, MIPS instruction architecture. Okay, these are the 5 levels of virtualization usually. Okay, and again, yeah, this is descriptive way. I just explained it. Okay, more maybe detailed way. Okay, so what I said, like usually these are all the program created for this instruction set cannot be executed on this. So you need to have a virtualization layer using instruction or ISA level of virtualization to achieve that. Okay. So it performs dynamic binary translation. That means the code that are execute or understandable by the underlying hardware. Okay. So the program will be converted instruction by instruction. So it will be a time consuming process because it will do a dynamic binary translation of the code. Okay, but still it is achievable to execute the code that are made for some other instruction set to get executed on a different instruction set. Okay, yeah, that's what I said, like a hardware as well, like utilizing the common hardware among a different maybe collection of virtual machines. Yeah, this is what I said. So when talking about virtual operating system level of virtualization, so you will be having hardware, okay, and you will be having a virtualization layer, which is nothing but OS virtualization here. So this is nothing but okay your LXC, so Linux environment, Linux kernel environment. So your guest OS can be any flavor of underlying one. Okay, so that is the thing you can have. And of course it achieves a higher maybe environment like efficient isolation, portability, all these things will be achieved by means of OS level of virtualization. And the library, yeah, I just talked about it as well. And example, you can say like a wine, Sigwin, CUDA, all those things will be there. And remember, what is the primary difference between library and hardware is you will not be creating an individual virtual machine here. You will be using user level libraries. Only libraries API calls will be converted rather than having a complete virtual machine, which makes it very lightweight rather than compared to a heavyweight virtual machine. Okay. And application level, of course, it actually sits on the top of the operating system as an application. So your JVM, whatever you are creating, it is nothing but it is just an application to your OS. Okay, your operating system will consider the installed JVM Java as a one of the application. Okay, so that is the case, like the whole application, whatever you are going to execute is completely virtualized. Okay, so these are the different levels. So here actually it explains how Java achieves interoperability over a different hardware using the JVM concept. And when following this, yeah, depends on the requirement. You can prefer anything. Okay, you can go for ISA or you can go for hardware, OS, runtime, whatever it is. But with respect to different criteria of performance evaluation, you can check it out like performance will be good, application flexibility, yeah, like you can execute different versions of application and complexity of implementation and isolation. This is not like this is done through practically having all this type of virtualization evaluated with all this performance factor. So it was identified like hardware level of virtualization is more efficient in achieving this performance factor. Okay, I can say like a trade-off wise, it is more efficient. And that is the reason like still people will be preferring hardware level of virtualization for this kind of or this better performance measure. Okay, even I can tell you like even your data center, whatever they are preferring, it's all hardware level virtualization. Yeah. When talk about virtualization, primarily we will be talking about one main component that is nothing but virtual machine manager, which is nothing but a layer that will be created over your hardware that manages everything. Just typical like your operating system. Like as a computer science faculty or any faculty, whenever we talk about operating system like your Windows and your Linux, all those things. So what actually it provides to the application? Primarily, they will be telling that it will provide you the environment to execute any kind of application. Your Windows environment, it provides space to execute some application. The application can be a Office, Windows, I mean Microsoft Office, or it can be a Photoshop, it can be a Maya, it can be anything. So your operating system gives you maybe the environment to execute some application. And next one, primarily, it provides the resources. Okay, so whenever your Maya, you're opening the application of Photoshop, the the processor, the RAM, the storage that are required for that application will be provided by the operating system. So when if you study about operating system, all these things will be learning. Now, assume like there is an environment where only directly hardware is there. Over that, you have a component called VMM. Okay, and you have a n number of virtual machine. Now, all the tasks, whatever I said now, your operating system does will be carried out by this particular VMM or hypervisor. Say example. Okay, it provides environment to okay environment for the programs to execute for all the same as a typical, maybe I can say like a native machine. So a person who is executing an application in this virtual machine, okay, he will think that he is utilizing the whole underlying hardware for his execution. Okay, that the impression or that particular virtual thing will be provided by this particular virtual machine manager, and it has to provide the environment, okay, that should make feel user, okay, like I can tell you like one thing, maybe I was telling like there is a translation, the operating system of, see, if I'm executing maybe Photoshop in this particular virtual machine, okay, and the code of the Photoshop will be given to this particular, the execution will be given to my operating system, maybe Windows, and this operating system code will not access the directly the hardware. The code will be given to my virtual machine manager, The virtual machine manager will execute on my hardware, and again it will be given back, and it will be given back, and it will be given back to my Photoshop. But if you see native machine, Photoshop code will be given to operating system. Operating system will execute and it will return back. So the operation will be only 3 layer. Directly it will be with operating system. But if you look at here what I explained, it will be 3 or 4 layers will be there. So surely there will be some kind of time delay because of the translation of the code. So what is the ultimate purpose of the virtual machine? It should be in such a way as minimal as possible. It can't completely eradicate it, but it has to make it efficient in such a way like as minimal. That is what it means. The program should run in this environment, should show only minimal decrease in time in the virtual environment. It should be it not possible same as a traditional computer. It should be as minimal as possible so that the user will not feel the delay. Okay, that is completely by the VMM. And also it should have a complete control of the hardware. So without the permission of this virtual machine manager, no virtual machine can access the underlying hardware. Because of security measure, isolation, all these concept, your VMM is nothing but the complete manager of all the underlying resources. No virtual machine operating system will be allowed to access the virtual, I can say like the hardware without the permission or maybe the control of the hypervisor. Okay, see, I will be using the interchangeably the term hypervisor, VMM, it's all same. Okay. And maybe I just go back. Yeah, these are just a comparison of different virtual machines. And yeah, I am going to talk about different types of virtualization. Okay, like in general, depends on where the virtualization layer is. Okay, usually there will be two types, type 1 and type 2. Is there anything? Okay, there will be type 1 and type 2 hypervisor, as I explained already, where it resides. So if it resides directly on the hardware, then the hypervisor will be type 1 or bare metal or native. And if the hypervisor lies within a host operating system, then it will be coming under type 2. Okay, this is based on where the virtualization layer is. Okay, and depending on the functionality, the hypervisor will be of two. One is microkernel and other one is monolithic. Maybe if you have come across operating system, you might know that because there is a concept of monolithic operating system, microkernel operating system. Okay, that is same here. So I can show with that diagram maybe. So I'm having hardware and I'm going to have a hypervisor over it. The hypervisor is going to have everything. Okay, the hypervisor is going to have like the basic functionality to provide maybe the environment for the VMs, the complete control, all the drivers that are required, all the security management, or all the extra maybe the functionality tools. Everything will be embedded with the particular hypervisor. That will be comes under called monolithic. One particular layer that will do all the tasks, all the management. Okay. Whereas microkernel is going to be some a kind where the hypervisor is not completely self-contained. Only basic functionalities will be there. All other extra functionalities can be maybe embedded, or maybe I can say like it can be used over it as a individual model. That will be comes under microkernelized hypervisor. Here hypervisor will not be complete. Okay. I can tell you your Windows operating system is complete, monolithic. It has everything. Whereas you take a second, please. So it is monolithic, and your if you take your Windows kernel, it is micro actually. Only the sorry. Okay, yeah. If you take Linux, actually your Linux kernel is only contains the minimal thing, and maybe the Fedora, all those things have drivers, all those maybe the extra functionalities. Similar to that, microkernelized hypervisor will have the preliminary requirements. All other extra requirements can be embedded over your hypervisor. Otherwise, the hypervisor will come with all the complete package. Okay, usually this will be maybe usually your proprietary hypervisors, whatever the provided by your VMware, Microsoft, all those will be coming under monolithic, and whichever the hypervisor that are open source, that will be coming usually under microkernel. Okay, hypervisor, where you can have hypervisor over that you can have your updated or maybe your tailored kind of management tools over it. Okay. And depending on the implementation technology, okay, hypervisor will be like a two using like a full virtualization, and other one will be para virtualization. Okay. And there is a conceptual explanation I planned, but I just time restricted. I just going to show a preliminary discussion. Okay. So remember, like you are executing some code. Okay. There are two types of code. With this explanation, I can say like there are each and every computer have there is something called the protection ring. Okay. The lowermost thing is called a ring zero, which where your operating system kernel resides. The ring zero, which have complete freedom of accessing the hardware. There is a next level of there is a highest level is called ring 3, which is nothing but all your user application, like whatever application you are executing, say your MS Office, your uh, browser, everything will execute at the layer 3. So what happens whenever you are trying to access the hardware, okay, or the shared resources, those instruction will be called as a privileged instruction. Okay, so whenever your application want to execute privileged instruction, they can't directly execute it. They have to give the control to the OS, otherwise the kernel. So the kernel will execute that privileged instruction on the hardware, and it will return back the control to the layer 3 application. So this is common in all the maybe like I can say like uh, systems, no matter of what is the operating system. So now if I take this,
Global system.
maybe now if you take this, so hardware will be there. Instead of operating system, you have a virtual machine that executes in the layer O or layer 0. And all your guest OS will be in the as a application. Now, whenever you want to execute some privileged instruction for that particular operating system, the operating system cannot execute directly. It has to pass it to the virtual machine, and virtual machine will execute it. Wait a minute. Maybe in the meantime, I can give a demo rather than talking. Maybe I'll stop this presentation. Yeah, I think. Mhm. I think I don't know what happened. I think it was working. Actually, I thought of showing you people like hosting multiple virtual machine on my system. Actually, that is the demo I just planned, but not sure. Like maybe Mhm. it was working just before the thing. Maybe I just closed the application. Maybe I have to restart my system. Might work. So, but I can't do it now anyway.